Salut à tous,
Salut
hello
tout le monde.
Salut Renaud,
Salut Charline,
tu vas bien?
je vais très très bien et toi?
Super, écoute, 7e édition,
Ouais,
le DevDay, ça y est, nous y sommes.
c'est ça.
Et en plus, spécial parce que c'est le DevDay qui vient chez vous, qui vient dans votre salon. Bravo d'avoir fait cette édition. Vous avez bravé le confinement, bravé le Covid, le DevDay, il est là.
Ouais, c'est une édition un peu spéciale cette année, c'est clair. Voilà, on a dû un peu revoir nos codes, chambouler toute la manière de faire de d'habitude. Et du coup, je remercie déjà tous nos sponsors qui nous ont accompagnés, qui nous aident à faire ce DevDay et à l'amener chez vous. Ouais, c'est vrai que c'est une année un peu spéciale.
C'est une année spéciale, mais ce qui est dingue, c'est que malgré ça, il y a une communauté de devs qui est à fond, qui soutient l'événement. Il y a un agenda, un line-up de speakers qui est dingue. Et puis surtout, on vous imagine nombreux et nombreuses derrière cet écran. Et voilà, cette journée, elle va ressembler. On a cette soirée, on a demain, on a du monde qui nous attend. On commence par quoi, du coup?
Écoute, on va commencer aujourd'hui par 3 keynotes de speakers internationaux qui vont nous parler de différentes choses. Aujourd'hui, on n'est pas dans des sujets hyper techniques, on est plutôt dans des sujets voilà, pour nous éveiller, pour nous inspirer. Et ça, en fait, c'est une journée d'introduction pour demain, parce que demain, en fait, on va avoir une trentaine de sessions là purement techniques, donc avec des développeurs qui vont parler aux développeurs, et là, vous aurez la possibilité de discuter avec ces développeurs sur notre channel Discord. Donc, vous branchez sur la plateforme de live stream. Et,
Donc, sur Discord, on y va tous, et c'est là où on pose les questions, c'est là où on fait les remarques.
Voilà, on est en live, on est en remote, mais ça reste interactif quand même.
Ah, c'est cool. C'est cool.
C'est évidemment ce qui est important, hein. Le DevDay, pour nous, c'est vraiment un événement où on veut avoir des échanges. Voilà, c'est pour ça qu'on a toujours fait quelque chose en présentiel. On veut que les développeurs se rencontrent. On veut que ce soit une journée communautaire. Et donc, voilà, il a fallu voir comment faire ça en ligne.
C'est trop bien.
Ouais.
On recrée les conditions. Du coup, on compte sur vous tous et toutes. Sentez-vous à l'aise, posez des questions, faites des remarques, balancez dans les Discord, on y va à fond, on se lance. Allez, let's go, c'est parti.
C'est parti.
Bon, vous avez bien retenu, c'est sur Discord que ça se passe, c'est là où toutes les questions, les remarques, les commentaires, c'est sur Discord, vous avez bien retenu. Mais il y a aussi Twitter, il y a aussi Facebook. Twitter, le compte c'est DevDay. Pareil pour la page sur Facebook, vous savez où nous retrouver et retrouver cette sensation sur toute communauté, c'est ça qui est important. Donc on espère vous voir nombreux, nombreuses, lâchez tous vos commentaires et surtout, dites-nous où vous êtes, votre ville, le pays, ça nous fait plaisir parce qu'on a l'impression d'être un petit peu avec vous. Et puis enfin, si vous savez aussi nous montrer un petit peu votre setup, petit canapé, petits chips sympa, on est content, on a l'impression d'être ensemble et c'est très cool. À tout de suite. Bienvenue Olivier, on est super content de te compter parmi nous pour cette 7e édition du DevDay. Écoute, Delaware, on comprend que voilà, c'est une boîte où toi tu exerces depuis quelques temps. Il y a des partis pris qui sont hyper forts. Déjà, dans un premier temps, est-ce que tu veux bien nous expliquer ce que c'est que Delaware et pourquoi vous êtes là aussi sur le DevDay finalement?
Alors, Delaware est une société qui a été créée en 1984, qui aujourd'hui compte plus de 1500 collaborateurs en Belgique et qui en fait se base principalement sur 2 domaines, donc l'excellence opérationnelle, l'expérience client. Et dans ces domaines, en fait, il y a beaucoup de métiers qui sont représentés chez Delaware. Donc l'excellence opérationnelle avec l'ERP, ça passe aussi par l'intelligence artificielle, les robots, tout ce qui est digital. Et moi, je suis Solution Lead Digital et je viens représenter en fait le domaine digital qui comprend beaucoup de développeurs de .NET. Donc voilà, c'est pour ça que je suis là aujourd'hui. Oui.
Exactement, là on se rencontre, on sait pourquoi on est là ensemble. Et justement, par rapport à ton expérience personnelle, on a eu des échanges un petit peu avant et moi j'adore ce message-là chez toi. De ton expérience personnelle, comment tu vois l'impact de l'éducation finalement dans le parcours du développeur?
Alors ça c'est une bonne question parce qu'aujourd'hui dans mon poste de team lead, je reçois beaucoup en fait de développeurs qui sortent des études ou de stagiaires et qui me demandent en fait est-ce que j'ai fait un graduat, est-ce que je dois continuer à faire des études et à faire un master ou mon graduat est suffisant en fait pour ma vie de développeur. Donc moi j'ai fait un graduat, je suis sorti il y a 20 ans d'un graduat, j'ai commencé comme analyste développeur. Et puis j'ai un peu changé de poste au fur et à mesure dans la même société. Donc je suis passé project manager, programme manager, account manager. J'ai eu un team en dessous de moi de project et programme manager. Je suis passé sales. Donc j'ai un parcours un peu...
très pluriel.
C'est ça, très pluriel, en commençant par analyse développeur. Donc une connaissance technique qui me permet d'aborder des problèmes architecturaux et techniques chez des clients. Et une connaissance un peu plus fonctionnelle qui permet aussi de comprendre leur business aujourd'hui et de pouvoir avoir des discussions, que ce soit business ou technique. Donc business avec les clients et technique avec mes équipes après. Oui.
Et du coup, ton expérience hyper plurielle, hyper multiple. Donc du coup, tu te dis, est-ce que tu as envie de permettre d'avoir cette même expérience pour les développeurs, pour les personnes qui rejoignent Delaware? Et comment ça se vit ça en mode équipe chez vous?
Alors mode équipe, en parlant d'expérience justement, en me servant de mon expérience personnelle aussi, ce qu'on voit, c'est qu'après 4-5 ans, généralement un développeur se pose des questions par rapport à lui. Donc il y a plusieurs voies possibles pour un développeur. Donc soit il veut avoir une expertise technique assez forte et se concentrer sur son expertise, être expert dans un domaine, dans une solution, dans un produit. C'est quelque chose qu'il a envie de faire. Soit on a des développeurs qui aimeraient bien évoluer vers un poste de plus lead, donc ils aimeraient bien s'occuper d'une équipe. Des développeurs qui, eux, veulent rester développeurs, donc pas experts, pas lead, veulent développer et être dans une équipe. Ou soit des gens qui vont évoluer vers des postes plus fonctionnels, donc project manager ou PO, donc product owner. Donc c'est un peu les 4 voies que je vois aujourd'hui dans le poste de développeur après 4 ou 5 ans. Et généralement, oui, c'est ça, c'est à partir de 5 ans qu'on se pose la question, donc qu'est-ce que j'ai envie de faire et comment j'ai envie d'évoluer en fait.
Et comment on les accompagne justement, ces gens-là qui se posent la question au bout de 5 ans, c'est quoi la suite pour moi? Comment Delaware les accompagne là-dessus?
Alors la chance qu'il faut avoir, c'est d'être dans justement une entreprise qui permet de faire ces 4 évolutions possibles et de pouvoir se dire à un moment donné, j'ai envie d'évoluer, j'ai envie de soit être expert et rester expert, et coacher des gens et des juniors qui vont arriver dans Delaware et leur apprendre des technologies. Soit j'ai envie de devenir project manager ou product owner, ou carrément changer de solution, ou changer de domaine, ou changer d'expertise. Et donc là, c'est ce que permet de faire Delaware aujourd'hui. Donc avec tous les domaines et toutes les solutions différentes qu'on a chez Delaware, on permet aux gens de soit d'évoluer, d'orienter leur carrière dans une des 4 positions que j'ai définies avant, soit de changer carrément de solution domaine. Donc quelqu'un qui fait du .NET aujourd'hui pourrait très bien faire du SAP demain parce qu'il voit un intérêt et parce qu'il a envie de changer de domaine. Oui.
Donc finalement, ce que tu dis, c'est que c'est pas tant l'éducation, les diplômes que tu as fait qui vont conditionner ta vie, ton parcours, ta carrière en tant que développeur, mais là tu dis on ouvre l'ordre des possibles et chez Delaware, du coup, format innovation, format formation, ça vous le permettez et les développeurs ont l'air d'être plutôt contents.
Tout à fait, oui, tout à fait. Donc c'est plus au niveau du management aussi. Donc chez Delaware, il y a un management qui est assez plat, pas beaucoup de hiérarchie. Donc ce qui permet aussi de prendre sa place dans la société, de proposer des choses et d'évoluer par rapport à ça. Au point de vue innovation, donc les développeurs pour proposer des frameworks. Donc s'ils voient quelque chose qui est bien et qu'ils aimeraient bien implémenter sur un projet, ils peuvent le faire. Ils peuvent aussi donner des idées d'innovation. Et on a aussi des gros projets d'innovation chez Delaware qui permettent de réaliser des innovations, que ce soit avec des clients ou en interne, sur des projets internes.
Donc vous laissez vraiment du temps consacré à ça.
On a beaucoup de temps et on a qu'on a un projet client, donc on se dit en fait qu'on a des experts qu'on envoie en formation. Ils reviennent en ayant appris des nouvelles technologies, mais ce qui manque souvent sont des projets pour exercer ces nouvelles technologies. Et donc là, on crée des communautés avec des clients et on demande aux clients en fait de proposer des projets. Et à ce moment-là, on met en fait des développeurs, on offre des jours de développement aux clients pour réaliser des projets et des projets innovants. Oui.
C'est génial. Écoute, on est super content de vous compter parmi nous. Le DevDay dit merci et bravo. Et puis surtout, longue vie à Delaware, évidemment. Merci à toi, Olivier.
Merci. Avec grand plaisir.
Et ça y est, on est parti, on est go, on est live. On commence avec la première session. Tu nous racontes, Renaud?
Oui, bien sûr. Donc la première session, ça va être avec Dr Silvia Quarteroni, qui travaille dans la science des données et donc qui est Principal Data Scientist au Swiss Data Science Center. Donc elle va nous parler de NLP. Donc c'est le Natural Language Processing ou le traitement du langage naturel. Donc ça parle de linguistique, de traitement de texte forcément, mais de manière intelligente.
Bien évidemment. Voilà. Bien évidemment. Allez, let's go.
C'est parti.
C'est parti.
Thank you, Charlene, for introducing me. The goal of my talk tonight is to tell you a bit about how we can teach machines how to read and write to us. As in my introduction, I come from a center that's called the Swiss Data Science Center. This is a center that's a joint venture between 2 federal institutes of technology in Switzerland. As you can see, in Switzerland, we love cheese so much that we even made buildings in the shape of cheese slices. And EPFL is indeed where I come from. So my role at the Swiss Data Science Center is to participate in our global mission to accelerate the adoption of data science and artificial intelligence in Switzerland. And the way that we are fulfilling this initiative that comes directly from the Swiss government is to be a large team of people related to data science who deliver collaborations with academia, so basically labs from different universities, but also collaborate with companies based in our country, Switzerland, in order to become more data-driven. And what I'm going to tell you tonight is very much related to this. We also have another initiative that's called Renku. Renku is a platform that is currently being developed in order to make data science more collaborative and data science experiments more traceable. You can check out all the details about where I come from on www.datascience.ch. But enough about that. My focus tonight is on a discipline that's called natural language processing. So NLP, in short, is actually a subfield of artificial intelligence. So artificial intelligence comes with many different domains, and NLP is one of them. And its goal is to understand and generate human language. Of course, if you think of the initial pioneering stages of artificial intelligence that were from the 1950s, there was this test called the Turing test from Alan Turing. The test said, a machine is going to pass the test if it can convincingly pretend it's a human. And recently, we have had examples of machines kind of passing this test, like, for example, Google Duplex, that's able to make phone calls to reserve appointments at hairdressers and restaurants. It's actually a chatbot, so a virtual assistant, if you like, that is able to pass as human. And indeed, although the field was born in 1950 and this year is 2020, we still have a lot of things to learn about. In a nutshell, natural language processing is the science of extracting meaning from human language, and it has many applications. Examples of NLP applications are spoken language understanding, so understanding what people say to machines and to other humans in a way that is comprehensive enough. Filtering automatically email based on the content, for example, detecting spam from ham, which is normal good email, and also automatically translating from a language to another. And the main tool of natural language processing today is not some formal linguistic theory, but it's actually machine learning. So machine learning, in a couple of words, is the ability of a machine to learn patterns from examples or to group similar cases together. And more recently, there's a lot of talk in the machine learning field about deep learning, which is actually a subgroup of machine learning methods where algorithms use complex structured called artificial neural networks in order to solve even harder problems than they did a few years before. The reason why, despite its 70-year-old career, natural language processing is still very cool today and probably cooler than ever is a sort of artificial intelligence hype that is being seen nowadays. Market players like Microsoft, for example, but also Google, Amazon, and many others release APIs and frameworks daily that allow you to do something with text, with audio. For example, they can automatically translate text. They can let you configure conversational assistants or chatbots in order to serve your business. And of course, there is another side to this, which is the actual consumers who are used to, for example, issuing voice commands to Amazon Alexa or Apple Siri, and who expect business applications of various kinds to support interaction in natural language. So this is why NLP is a particularly nice topic to work on nowadays. But then you can ask, I mean, the discipline's been going on for like 70 years. How hard can it be? And actually, it turns out that human language is quite hard because of its ambiguity, which means that you require the context of a conversation, the context of a sentence in order to really understand what it means. If we take newspapers, these are classic examples of cases where people have a very limited number of words that they can use, for example, when they write titles, and they need to be super compact and super effective. But sometimes you miss some words, and it requires a human kind of intelligence to understand what exactly is meant. If you take this example here, a doctor, no heart, cognitive issues, but Trump needs to reduce his cholesterol and lose weight. Well, here you can interpret this title in several different ways. You can think that the doctor says that Trump has no heart and has cognitive issues, or on the other hand, the doctor is reassuring that Trump has none of these. And the way you interpret this requires your more global understanding and maybe also opinions about the specific person that Trump is. Another example, which is kind of funny in a grotesque way, is this one. Mutilated body washes up on Rio Beach to be used for Olympics beach volleyball. So obviously, the thing that's going to be used for volleyball is the beach and not the mutilated body. But you as a human understand this because you have a kind of intrinsic knowledge of the world. The machine potentially has no reason to make this mapping for from volleyball to beach more frequently than from volleyball to mutilated body. And finally, in case any French speaker is following this keynote, this is a recent piece of news that I read on the 20 Minutes, so one of the local newspapers, if we may call it this way. So here it says, according to a study, buyers still prefer to go to shops in order to buy Swiss watches. And this is because of an emotional link that's created by manipulating them. And of course, this is a kind of sneaky ambiguity, right? Because what's being manipulated? Is it the customer that manipulates the watch, as the person writing the article probably meant? Or is it that, you know, the sales assistants want to manipulate the customer, and that's why people still kind of tend to go to the shops? We will never know. In any case, I hope I have convinced you that understanding natural language has its complexities, and these are basically related to the idea of putting words in a context. And indeed, capturing the context of language is one of the main challenges of the field of NLP since its foundation. The first, ideas about natural language processing follow the principle that the meaning of a word is determined by the words around it. So you shall know a word by the company it keeps. And this is kind of an intuition that has been going around since approximately 1956. And indeed, intuitively, you can understand that similar words tend to appear in similar contexts. And this is quite a powerful intuition. And it's an intuition that people have been trying to exploit commercially a bit later. So starting from the 70s, people tried to understand how they could represent words and their context in a way that would make calculating similarity between words something more systematic, something that they could employ in computer software. And the vector space model that's in this title here is what came out of this reasoning. So vector space model is a complicated term to express quite a simple idea, which is the following. There's a multidimensional space, which has as many dimensions as there are words in a vocabulary. So you can imagine that in this picture, which has three terms, term 1, term 2, and term n, these terms could be cat, dog, and fish. And then given that the world is fully described by these three terms, sentences can be described also as combinations of these terms or vectors. A vector is nothing else than a list of numbers, if you like, an array for developers. So if a sentence contains dog and cat, it will be somewhere in the middle between the axis of dog and the axis of cat. If it contains dog and fish, it will be somewhere in the middle between the axis corresponding to dog and the one corresponding to fish. So the bottom line is, if you kind of scale this up to thousands and thousands of terms, like the ones you could find in a vocabulary contains more than 1,000 words, and you take any kind of sentence, you can kind of plot this sentence as a vector in this space. And why would you want to do that? Well, it's kind of intuitive once you have two vectors that you can compute their distance using classic geometry. So you compute the angle between these two vectors, and the smaller the angle is, the closer these two vectors are. So in some way, you can approximate the similarity in meaning between two words or two sentences or even two documents in terms of the vector similarity, which is a mathematical context, concept that is very easy to compute by a machine. And indeed, if you think of one classic example of computing distances between documents and distances between queries and documents, you have search engines, right? So starting from the 90s, this whole idea became very profitable when it was included into the major search engines. So in a search engine context, what you have is you have a question, something like, I don't know, when was Shakespeare born? And you have lots of potential documents in a database of documents that can be used in order to kind of assess how close the document is to the question at hand. And you can rank documents according to their similarity to the question, for example, based on the number of common words that they have with the question. So you would score Shakespeare was born in 1564 higher than you would score Blake was born in 1757, because there are more common words between the first answer and the question than between the second answer and the question. So this is all kind of established. And indeed, most natural language processing applications since the 1990s actually boil down to this quite, let's say, simple, mathematically speaking, intuition. Indeed, we can group most of the applications that use NLP into three core tasks or functionalities, if you like. One is classification, which is basically determine what category a text belongs with. And examples of these classification tasks include sentiment analysis, or categorizing news by their topics, or even spam filtering, so determining whether an email is useful or not. You have another kind of task, which is slightly different. It's called extraction. So here, instead of taking a text and putting a label on it, you actually read the text and you try to extract meaningful, useful entities from there. I will make some examples later. And finally, a third task, which is called generation. And here the goal is to create a sort of a sequence of tokens, or let's say a sequence of words based on a context. So for example, you have a sentence in French and you want to convert that into a sentence in English. So you have to generate word by word the corresponding words to the words in the French sentence originally. Or you have a large document that you want to automatically summarize. So you start with a sequence of words that kind of make up the document, and you want to convert this into a paragraph that is the summarized version of the document that you were submitting as the input. So if we go a little bit deeper in detail, and I try to explain you why I was saying before that we use a lot of machine learning when it comes to understanding text. Text classification is an example of this. As Jeff Bezos, who's the CEO of Amazon, said, in the past, it was kind of relatively easy to solve some classification problems using rules and algorithms that could exactly describe what types of information would be funneled in a direction or another. But more recently, it's even more powerful to use, other approaches in order to solve tasks where it's hard to describe a precise rule. And indeed, the idea of text classification is to identify the class of a text by taking a machine learning algorithm, in particular supervised learning algorithms. And the supervision consists in the fact that you will give a machine examples of text with their labels, and the machine will automatically learn how to give correct labels to new examples of text that it has never seen. So if we take the example of news articles categorization, you might have a newspaper with lots of technology articles, lots of sports articles, lots of fashion articles, and you might have the question of what's the next article going to be categorized under. And if you've been able to train a machine to see enough examples of technology, of sports, and of fashion, the machine will kind of know what is the word distribution that will allow you to take a totally new and unlabeled article and kind of map it to the closest group of articles, and therefore kind of automatically give a label to the new article that you're feeding it. In information extraction, as I was mentioning before, the idea is to try to automatically guess interesting parts of text, where interesting, of course, depends on your business. So if you're, for example, again, a media agency, you might take a newspaper article and you may want to automatically extract things like dates or names of people that are mentioned or organizations and locations without knowing that list in advance. And to do so, you can use a machine learning approach. So you can train a machine learning algorithm to recognize what is meaningful to you by showing it a piece of text where the things of interest, if you like, are highlighted. So the machine learning algorithm will learn to look at the neighborhood of the words that are actual entities of interest, such as United States or Adolf Hitler, for example. And when it's given new examples of text with even unknown words, it will try its best to guess what are the bits of that text that are of interest. And you can imagine that this is useful in many different fields. So you can have, for example, in a biomedical text, you could imagine that the entities of interest are no longer dates and names of people and organizations, but instead they are substances like, for example, gentamicin sulfate, and conditions like renal failure or decreased renal function. So the goal of these is to, of course, digest a large amount of text without actually having human people read all the details, but kind of having information that pops out from them. And by the way, in these fields, it's not that everything is carried out using a machine learning approach. If you, for example, are a bank and you want to analyze some communication from a customer, if the customer mentions an email address or an IBAN code, of course, you don't want to reinvent the wheel. We know that an email always contains, a @ sign, or that IBANs have a fixed structure. So for those, we won't use learning approaches. But in many cases, where we don't have the luxury of being able to define what are the patterns that actually make sense, then we will resort to supervised learning approaches. So an example just to fully convince you of this is quite a classic, I would say, Paris Hilton. If you find the text Paris Hilton in a larger text, it can refer to either a person or a hotel. The Paris here can refer to a location or it can refer to a person. And based on the context in which it appears, these words will have a different meaning. So it's essential to think at least of using a machine learning approach to solve the problem of correctly extracting pieces of information that are of interest to us. And well, I guess from these examples, I kind of partly have interested you, but also partly have given you the idea that it's quite complicated to put together a system that is able to do all of this. And indeed, this was particularly true until a few years ago, because both research and industry focused on ways to do this that are called feature-rich. So what happened was the following thing. As an output, so as a result of what you were doing, you wanted to have things like sentiment analysis, so classifying text as either positive, negative, or neutral, classification of some kind, for example, classifying newspaper articles by topic, automatic translation, and many other tasks. As the input, you would have a bunch of documents, and then in order to get there, you would have to basically carefully handcraft a number of pre-processing and modeling steps in order to get to your dedicated application. So if you had to, for example, make an automatic sentiment analyzer, what you would need to do is, given some example documents, you would have to, first of all, detect the language of the document. Then for each language, kind of split the document into its words, analyze the words, for example, filter out words that are not particularly meaningful, such as determiners, a, the, and so on, prepositions like at, to, from, and so on, and just keep the juicy words. And then from there, model the problem. So do things like, all right, I want to do sentiment analysis. So probably if I want to feel if I want to find documents that contain some sort of feeling, there will be a lot of adjectives like good and bad, and maybe not a lot of nouns like cat and person. So I might, find the features in the text, so characteristics of the text that focus on the presence or absence of adjectives. Or maybe I will look for punctuation marks, because if people are really angry at something, they will use exclamation marks and so on. And many of these steps you would need to define in a sort of very manual way. And by the way, if you wanted to kind of solve another problem, which could be maybe classifying text, but according to another type of classification, like by topic, you would need to go through this whole pipeline again, but maybe carefully selecting your features, so the characteristics of text that you focused on, in a way that would solve the specific problem of classifying by category. So obviously, there was a lot of manpower dedicated to this, and it wasn't possible to manually do this on a vast amount of text. You would have very few cases, very few data sets available that would allow you to do this in a very systematic way, and only big companies or big research labs would have the ability to create data sets to learn from using machine learning. And lately, there was a kind of watershed moment, which was signaled by the usage of deep learning into the NLP community. So deep learning, really in a couple of words, is an area of machine learning that generates its models, so its representations of the text or other, let's say, phenomena, using a particular family of methods called deep neural networks. And it has really changed the way, revolutionized even the way we think of machine learning problems. The first real, boom of these techniques was in computer vision. So the automatic, the fact of teaching machines to see things as human people do. And this happened about around 2005 or so. And more recently, natural language processing also kind of took an inspiration from there. In deep learning, what happens is you don't really worry about describing and pre-digesting the problem of learning for the machine. For example, in computer vision, you just feed an entire image into a big black box, if you like, that's called the neural network. And the neural network will learn by itself what are the characteristics of the pixels and the groups of pixels that really make it say in the end, this picture contains a dog, this picture contains a cat, and so on. So you don't do, in the previous slide that I showed you, you don't do a lot of handcrafted feature engineering here. You just let it learn. And indeed, in natural language processing, a key way to do this is the concept of an embedding. Embedding is a fancy word that is really hinting at the idea of representing the meaning of the word, of any word, in a compact way. What is the relationship between embeddings and deep learning? Well, it turns out that embeddings are kind of a byproduct of training a neural network, so a deep learning architecture, if you like, to solve a specific task. And this task is a kind of fill-the-blank task. So imagine you take the whole of Wikipedia, and then randomly you remove some words from the text, and then you give the whole thing to a neural network, and you tell the neural network hears the whole of Wikipedia, predict what's the missing word in each blank. Obviously, if you give this task to even a human who is trying to learn a language, by repeatedly seeing the same words in kind of different contexts, it will be able to guess what is the missing word in the blank, and so does the neural network. And actually, by doing this exercise of seeing a massive amount of text and being able to guess the next word, by the time it's finished, with the whole of Wikipedia, for example, the neural network will be able to appropriately have an interpretation of the meaning of a word. Specifically, the meaning of the word will be kind of a sort of combination of different contexts in which the word has appeared. And the output of the neural network, when it comes to representing the word, will be this kind of vector, like in the examples that I presented before. Only these vectors will be much, much more compact, shorter, so shorter arrays, and much more meaningful. They're kind of a condensed representation of what the neural network has seen throughout lots and lots of learning cycles or epochs. And to make this a bit more concrete, I would like to show you this example. So it's not vital that you can read each and every little number, but and each and every little word. But what you can see here is basically a representation in a 2D plot, so a two-dimensional picture of a number of words that are found in a newspaper dataset from the Reuters agency. And their positions are basically the result of plotting the embeddings, so these compact vectors, into the space. So what's kind of interesting here is that if you zoom randomly on a piece of this plot, you can see interesting things. You can see that automatically these neural networks have learned the meanings of similar words. For example, if you look at this zoom here, you can see that increased and rose and also fell and declined appear very close together because they are mentioned in the same context. So eventually they will be bound to have a similar vector, and therefore if you say similar vectors, you can say computing the distance will result in a very low distance, so you can kind of use this as the starting point to represent that word in a context. You can see days, years, and months also appear close together. You see here president and chairman in red. They also have very similar, their points are almost superimposed. So what I'm trying to say here is that when you use these embeddings vectors that are the byproduct of learning with deep learning methods, you end up with these very powerful and nifty representations of text that are really good at capturing associations. And this was kind of a surprise in the last 10 years or so that people had when replacing the idea of manually figuring out what would make two words similar with this idea of just feeding the whole thing to a neural network and crossing their fingers for the result. And one thing that I want to mention here is that the reason why these kind of interesting associations and meanings kind of surface up from embeddings is because the neural networks that are that these embeddings come from have been trained from massive amounts of data. And the reason they could have been trained by massive amounts of data is because it is no longer necessary to kind of feed them data with a label that's given by a human annotator. They can just be fed the entire Wikipedia and kind of have a self-supervised, as it's called, way to learn. And another thing that I want to mention is that given that these embeddings are so powerful at capturing ultimately the meaning of words, using them as the starting point to any subsequent natural language processing application is a very good starting position. Because on the one hand, it removes the need for complex engineering of the different features. And from the other, it removes the need for coming up with hand-labeled data, which is super expensive to create, and especially so in languages that are not as frequently spoken as English, French, or Chinese, for example. So today, what you have is that many sources from different companies are freely available for, having embeddings vectors that you can integrate into your own downstream application. So what you have effectively is a different kind of approach to natural language processing in general, which is first and foremost you get to these embeddings, and once you have these embeddings, you can typically tweak a bit neural network and get as an output a multitude of applications that are kind of more readily available for you to exploit than before, where you needed to handcraft your solution for each and every single application that you were interested in. So, okay, the theory is now behind us. Now I would like to show you some concrete examples of what you can actually do with all of this nice natural language processing stuff that I mentioned before. And to do this, I would like to draw some examples from some industries here in Switzerland. As you can guess, we have a lot of watchmaking, we have a lot of banking, we have NGOs, and then we have a bit of a mix when it comes to virtual assistants. So I cannot really cite the names here, but I would like to tell you about a project that I was involved with a few years ago from a luxury watchmaker in Switzerland. So this watchmaker has a commercial department that owns a knowledge base about its products, brands, and services. And this is a French, it's a knowledge base written in French. So in this knowledge base, you would have things like how can, waterproofing be ensured in this particular, piece of the watch. And then after the question, you would have a number of answers by experts with sometimes very technical terms. And the goal that they had in this commercial department was to ensure that any new questions asked by customers would be kind of matched with existing ones in order to avoid creating duplicate knowledge base entries, so to make the whole knowledge base more maintainable. Ultimately, they also wanted to offer these question-answer pairs as the backbone to a chatbot. So if a customer would come and say, I spilled some, French fries over my bracelet, my watch bracelet, how can I clean it? They would kind of hopefully be mapped into proper cleaning of materials involved in the watch or something like that. So what we did was we defined a question similarity function. So basically a sort of recipe for matching questions that was based on a representation of the domain, so the world of this watchmaker. And this is not quite the emphasis of my talk here. But the second ingredient of how we solved the problem were word embeddings. So we tried to learn these embeddings representing the watchmaker's world in a way that would kind of maximally capture all the possible meanings that words in their brand would have. So what we did was take a bunch of documents from the watches, so the official technical documentation and specifications of watches from the brand. Then we took a number of pages on the French Wikipedia talking about watchmaking. And then just to make sure we would be able to capture, normal French conversation text, we took also examples from French text. And we kind of generated custom embeddings, so custom word representations for this particular customer and his particular business domain. And using these representations, we could then match questions together, even though these questions didn't necessarily contain the same words, just because the embeddings of their words were similar, were close together. So if anybody speaks French here, we would have questions like, can you find a shop from the brand? And this question would be kind of matched with list of retailers from the brand. And as you can see here, between the first question and the second and the first answer, there are no common words. On the top, you have magasin, which is shop, and on the bottom, you have détaillant, which is retailer. But still, since magasin and détaillant have a similar embedding vector, they were matched together. And indeed, this is a very useful match. Or if you would ask something like how to clean a bracelet in elastomer, which is the material of the one potential material for bracelets of watches from this particular brand, the one answer that was found to match was the one regarding taking care, so entretien, instead of nettoyer, which is clean, of bracelets with a brand name for that material. So instead of elastomer, you would have, a brand name that kind of meant elastomer, but in a more fancy way. Or another example, so people could be asking something about this specific hairspring device, which is what makes the watch move. And in French, this is called courbe terminale de Breguet. You would have a question called spelling something like, how does the spiral and with the name of the brand name of the spiral matched with this particular thing. So these kind of automatically found pairings reveal the fact that using these words and word embeddings, we have been able to really understand what the different words in the watchmaking field really meant, and we have been able to match them sufficiently well in order to find these kind of synonym questions. Here we have another example from an NGO. So as you may know, in Geneva, there are lots of non-governmental organizations. And the one that we were dealing with in this particular example is actually one of the oldest NGOs ever. They have about 12,000 employees worldwide, and they are responsible since the 19th century for the historical memory of international conflict. So what they need to do as part of their mandate is to select and archive exchanges that take place between the headquarters and their field offices. What they need to do is basically distinguish emails that are ordinary emails from emails that have a meaning and need to be carefully kept for the future. For example, these could be emails talking about diplomatic visits or visits to prison installments that would kind of serve as the basis for legal cases in the future. And, manually going through all of these emails and selecting them and mapping them to a classification sort of in a library kind of way is a very, very heavy task to perform, because annually this NGO generates about 1 million emails, and these have to be classified into 3,000 possible classes. So people from this NGO came to us and asked us, is it possible to at least partially automate this classification task? So is it possible to map an email into one of these 3,000 classes? And in order to do so, we proposed to make an experiment with about 5,000 emails in order to learn classifiers using machine learning. And the machine learning method that we chose was a combination between classic machine learning approach, so one of the many ways there are to learn from labeled data, and representations of the words in these emails coming from the embeddings that I mentioned up until now. And when we did this, we realized that we have over 90% accuracy in identifying the correct class of these emails. And 90%, of course, is not 100%, but you have to think that also humans make mistakes. So sometimes humans make more mistakes than machines, and also choosing between 5,000 possible values is quite a complicated matter. So it's much harder than choosing between, for example, 2 values. So this 90% is quite a good result in our opinion. Another example that I would like to propose comes from a Swiss bank. So in this case, context is very different. A private bank based in Geneva They are, of course, very active on the media, and they try to communicate in the news about a number of themes. These could be, for example, an arts prize that they support, or a green energy products for which they have particular financial packages, and so on. And what they wanted to know with our help was whether they communicated enough about relevant topics that would be mentioned in general in the news, and also what would their competitors do in order to communicate. So if there were some opportunities for more communication in topics that they didn't think of. And how we addressed this problem was to analyze financial news in order to kind of derive automatically some relevant topics from the texts, and then understand, create a sort of topic map regarding the whole space of communication in the news about finance, in order to understand where this bank, which in this picture is Red Bank, would be positioned compared to other banks. So what we have here is a kind of blurry, artificially blurred, I'm sorry, representation of all the financial news topics that we could automatically identify. So for example, here you can see that the green group of points is the finance point. The purple group of points is the sports point, and so on and so forth. And what you could see is kind of where in these different topics, the bank that was our customer would communicate. So you can see that, for example, there are not so many red points in the orange cluster. So maybe this bank could communicate a bit more in this topic, which I believe was the arts topic, because, you know, the competition, which is the blue guys here, actually made a lot of articles in this topic. So these tools that derive from basically a massive analysis of a really large amount of text that comes from free sources, that comes from the web, basically, these kinds of analysis can serve the purpose of making content creators aware of what are their communication opportunities. And yeah, so one point that is similar to what I was presenting before when I talked about embeddings is that indeed similar. So these points are articles, and similar articles in this visualization appear in the same region. And indeed, you can see that similar articles will also be similar in terms not only of the words they contain, but the general topics that they involve. The last example that I would like to present tonight regards virtual assistants, because virtual assistants are a very good opportunity to explain natural language processing and its abilities. And probably many of you have been using them or have been victims of them at some point in your recent, browsing experience. So what are these? They are conversational virtual agents. Actually, virtual assistants have been around since the 60s. One of the most successful chatbots of the 60s was called Eliza, and basically it simulated a psychotherapist. So it's not such a recent invention that of creating a conversational machine that's going to keep talking to you as long as you keep talking to it. What is new is that today their main use is to basically give you some information, or rather sell you some product. And this is why many companies actually have chatbots on their websites. The main field where virtual assistants are present is in omni-channel customer care. So whoever has a customer care channel or channels will most likely resort to virtual assistants at some point. So you can find this in finance, like banks, and others, manufacturing, retail, health and insurance, but also public transportation. Like you can have chatbots that tell you what is the best train and bus connection from your starting point to your destination point, and many other fields. And the way virtual assistants work today is quite simple, actually. First, they try to identify what it is that you want to do with them. And then they kind of follow a recipe in order to achieve that task. So, for example, if you want to use a virtual assistant to make a hotel booking, you will say something like, I want to find a room in Lausanne. It will automatically be identified as a hotel booking kind of goal of yours. And then the chatbot is going to keep asking you questions such as, when would you like to check in? When would you like to check out? How many people? And so on, until it's able to kind of fulfill your request. So make it a request through a booking API, for example, so that there is a monetary transaction taking place at some point. And both the initial part, which is figuring out what you want to do from your first statement, to the recipe fulfilling part, both of these steps are heavily based on machine learning. Just so you know, there's a lot of chatbot frameworks around. For example, you will have Azure Bot Service and Luis AI from Microsoft, but also, of course, Facebook, Amazon, Google have all have their APIs to develop chatbots. It is kind of relatively easy to get from zero to a sort of starting basic functionality chatbot nowadays. The hard part is probably figuring out which platform to select and how to kind of dress up the conversation in a natural way. So a typical architecture that you may think of is the following. You have, you start your conversation with the chatbot, and you can do that through different channels. So these can be, for example, Facebook Messenger, Amazon Alexa, WhatsApp, Skype, or even the phone. And then you will optionally, depending whether it's an oral channel or a written channel, you will have a speech-to-text converter, which will ultimately give you a sequence of words that the chatbot will receive as its input. And then it calls a component called natural language understanding that tries to figure out what you want to do. So it classifies your utterance, your statement, into one of the N things that it can do. And then it will feed this to a component called the dialogue manager, whose goal is to plan what to say next to you. So the dialogue manager, given the context of the conversation, given what you want to do, and given, for example, information that it would have through a backbone system like an API or databases, it will know what to tell you, and it will kind of want to render it to you in a textual way. And once this is done, you will optionally have a module or a component called the text-to-speech synthesizer, which is able to then generate the spoken version of what the chatbot wants to tell you. And dressing up a chatbot is basically the configuration of these different modules and their specification according to your own backend systems that represent your business logic. Examples of chatbots can be found in many, many different modalities and many different contexts. For example, here in Switzerland, we have, when somebody tries to deliver us a package and we're not home, we get this dreaded yellow card that says, we haven't been able to deliver you this package, please check out with the local post office or something. But wouldn't it be cool to kind of scan the QR code that corresponds to your package and automatically being able to ask via, for example, Facebook Messenger, when will I get my parcel? Where is it stock? What can I do? Things like that. Or even if I have, a smart home device like Amazon Echo Dot, say something like, Alexa, where is my parcel? Where is my parcel from Amazon, for example? And these are things that you can easily do using a central logic that you can configure that interacts through different channels. Another example that I can make here is in the customer care domain. So this is a screenshot taken a while ago from the web page of PostFinance, which is one of the largest retail banks in Switzerland. And PostFinance is a bank that serves quite a few customers, and as you can imagine, many of them have questions. For example, have I already received my monthly payslip on my account? And some of these questions are really easy to answer, but regardless, like people don't really go into their e-banking account, they rather pick up the phone and call the bank. So this generates a lot of work for the call centers, and one way to kind of release this, relieve this stress is to maybe put a chatbot in the bank website and try to kind of absorb a number of questions through there. Or maybe people could be interested in knowing what is the closest agency that they can go to in order to open an account or book an appointment. And basically, many of these tasks, about 150 of these tasks, could be automated using what they call here digitaler assistant. So a digital assistant or chatbot that was able to solve different kinds of questions in a way that would not involve interacting with a human operator. Basically, this is the end of my talk. So what I hope you can take away from all that I've said is that natural language processing as a field, it basically means understanding how human language can be generated and analyzed by computers. But also, it's kind of a rediscovery of human language through the eyes and the ears of machines. So the intuitions that we had in the 50s about, the word's meaning is determined by its context are actually very much current now when we have word embeddings to represent word meaning through vectors. And we use them in very fancy tools like Google Search and Amazon Alexa's functionalities. And indeed, where do we stand today? Well, there has been some recent progress thanks in part to deep learning that allowed IT giants to create quite impressive applications and of course a lot of profit coming with that. But it is also true that sometimes machines still struggle to understand us. In any case, we can confirm some of our assumptions and intuitions about language. So this is quite an interesting field to be working in. With this, I would like to thank you all for your attention. If you have any questions for me, you can write me an email at the address that is provided here. And also, I can point you to the Twitter account of my group, which is the Swiss Data Science Center. So as you see, Data Science Twitter handle. Thank you very much.
Bon, vous avez vu, on a commencé très fort avec cette session et en plus, c'est une femme qui a fait cette première keynote, donc on est absolument ravis. Le sujet NLP, tu connais Thomas?
Ouais, un petit peu, ouais, super session. Évidemment, NLP, énormément d'implications, comme on l'a dit déjà aujourd'hui dans le monde et pour les développeurs, donc super intéressant.
Exactement. Et toi, Thomas, du coup, tu viens de Microsoft, n'est-ce pas?
Oui, tout à fait.
Alors, explique-nous ce que tu fais chez Microsoft.
Alors, tout simplement, j'aide mes clients en Belgique, dans principalement le secteur public, à définir et à exécuter leur stratégie digitale. Okay. Et avant ça, j'étais aussi architecte cloud, avec un focus sur tout ce qui est intelligence artificielle, justement, et tout ce qui est data. Donc, l'IA... Ça, c'est ton sujet, ça, c'est ton petit bébé. Comment tu trouves que, parce que là, on est sur le DevDay, tu vois bien, donc on veut parler aux développeurs, comment ça va changer la routine du développeur, finalement, l'IA? Ouais, ça va changer effectivement la routine du développeur et de plein d'autres personnes, hein, évidemment. Mais clairement, pour les développeurs, évidemment, c'est une immense opportunité, on est d'accord. Hein. On en a parlé avec le NLP, par exemple, tous ces modèles qui sont préfabriqués que les développeurs peuvent utiliser directement dans leur application. C'est hyper simple, hyper rapide, pas besoin d'être un data scientist pour pouvoir utiliser l'IA aujourd'hui. Donc ça, c'est génial, immense opportunité. Ça vient aussi avec un certain challenge, hein, pour être honnête. Il faut bien comprendre ce qui se passe. On parle là parfois de l'opacité de certains modèles. Si on fait un peu le parallèle avec un concept très simple, le debugging, quelque chose qu'on fait depuis toujours, qu'on fait très bien. On a vraiment aujourd'hui les outils parfaits pour pouvoir comprendre ce qu'un bout de code fait exactement, dans tous les détails, comment le code se comporte. Et bien, ce concept-là de debugging, si on regarde pour un projet d'intelligence artificielle, on n'est pas du tout au même niveau. On n'arrive pas pour tous les modèles à arriver à comprendre exactement pourquoi
une telle prédiction a été faite, par exemple. Donc ça, c'est hyper intéressant de voir qu'il y a plein d'outils qui commencent à se développer. Par exemple, il y a des librairies, pour en citer une, InterpretML, par exemple, quelque chose qui travaille là-dedans. Mais on n'est pas du tout encore au même niveau, et je pense que dans les années à venir, c'est quelque chose qui va énormément grandir pour arriver justement à cette transparence de tous les modèles.
À cette transparence, exactement. Ce qui reste un petit peu opaque aujourd'hui, au fur et à mesure, tu espères que ça va être beaucoup plus transparent et beaucoup plus manageable aussi pour le développeur finalement, qu'il soit vachement acteur. Donc le développeur, ça c'est une chose, mais aussi dans la partie Ops, finalement, dans la partie opération, ça se passe comment en fait?
Oui, c'est une très bonne question parce qu'effectivement, je pense que c'est un challenge qui a toujours un peu existé entre il y a les développeurs, il y a les opérations, mais aujourd'hui c'est encore un cran plus haut, je pense, ce challenge avec les projets d'intelligence artificielle. Si je simplifie énormément, on a quoi? Typiquement, on a du code qui va être développé dans un environnement de développement, quelques tests, et puis du code qui va arriver dans un système en production, très simplifié. Ouais. Aujourd'hui, avec des modèles d'intelligence artificielle, on rajoute dans cette équation le modèle en tant que tel.
Ouais, c'est ça.
On rajoute également les données qui nourrissent ce modèle. Et donc, ce sont des éléments qui doivent être monitorés, qui doivent être opérationnalisés. Et donc, on voit là qu'il y a vraiment la collaboration entre les développeurs, les data scientists et les gens des opérations qui doit vraiment être encore plus renforcée.
Encore plus soudée.
Encore plus soudée.
Ouais.
Et donc, on va mettre en place des choses, par exemple, pour regarder les données qui rentrent dans le modèle. Peut-être qu'à un certain moment, elles vont devenir fort différentes des données avec lesquelles j'avais entraîné mon modèle. Et donc là, il va falloir, par exemple, activer un réentraînement de mon modèle avec ces nouvelles données, par exemple, toutes des choses comme ça. Et là, je parle uniquement d'un modèle, mais aujourd'hui, les entreprises utilisent des centaines, des milliers parfois de modèles pour un problème donné. Et donc, comment gérer tous ces différents modèles, leurs différentes versions, utiliser quel modèle à quel moment. Tout ça, c'est en fait un nouveau besoin qui est en train de se créer tout simplement. Et donc, avec ce besoin, de nouvelles solutions aussi qui viennent solutionner ce besoin.
Et un besoin d'accompagnement, j'imagine, comme tu le disais tout à l'heure finalement, parce qu'on commence, donc on a plus de questions aujourd'hui certainement que de réponses, mais tu restes optimiste et ça, c'est cool. Là, on a parlé de la routine du développeur, aussi de l'Ops. Est-ce que finalement, ce long terme, le métier de développeur, on parle bien du métier, est-ce qu'il va changer, évoluer? Est-ce que le positionnement du développeur ou de la développeuse d'ailleurs va être différent?
Oui, je pense, honnêtement, je pense, et pas que le métier du développeur, le métier de beaucoup de personnes probablement, mais pour les développeurs, évidemment, je pense qu'il faut être clair et je pense que la plupart des gens sont d'accord avec ça. L'intelligence artificielle ne va pas remplacer le développeur, l'intelligence artificielle va augmenter les capacités du développeur. Et donc pour ça, par exemple, Microsoft a défini 7 principes de l'intelligence artificielle pour une IA éthique. Et donc là-dedans, il est question, par exemple, comme on parlait de la transparence tout à l'heure, transparence des modèles. Il est question aussi de choses comme le biais des modèles, quelque chose de très important. Le biais, c'est quelque chose qui existe dans la société partout autour de nous. Mais parfois, ce biais se retrouve amplifié dans les modèles qu'on crée, de sorte que les modèles ne représentent plus tout à fait la réalité, mais une réalité un petit peu tronquée. Donc ça, c'est quelque chose de très important auquel il faut faire attention et c'est la responsabilité de tout le monde, pas uniquement les gens qui créent les modèles, mais les développeurs, le business qui les utilisent. Tout le monde doit en être conscient pour pouvoir poser les bonnes questions. Donc ça, c'est, je vais dire, comment faire ça correctement. Une fois que ça c'est sous contrôle, on peut commencer à regarder des choses totalement fascinantes pour les développeurs grâce à l'IA, comme par exemple, il y a un projet de recherche que Microsoft a fait avec OpenAI, où ils ont scanné des milliers de repositories sur GitHub de code, et sur base de ça, ils ont créé un système qui permet de générer automatiquement du code. Donc, c'est-à-dire que moi, je peux écrire la première ligne d'une fonction de code.
Et ça va générer...
J'écris également la spécification en commentaire, typiquement, comme ce qu'on fait en anglais, cette fonction doit calculer, blablabla. Sur base de ça, automatiquement, ça va générer le code pour pouvoir implémenter cette fonction. Donc c'est assez fou. C'est des projets de recherche qui, d'ailleurs, aujourd'hui, ont des retombées tout à fait concrètes. Si vous allez voir dans Visual Studio, par exemple, il y a une extension qui s'appelle IntelliCode, et ça écrit pas encore tout le code à ma place. Peut-être que ça arrivera un jour, mais non, ce que ça fait, c'est que ça donne des suggestions de bout de code, un peu comme quand je suis sur mon GSM et je tape BAN, ça me propose banane, par exemple. Ça fait la même chose, mais pour du code.
Ça, c'est cool parce que finalement, ce que tu dis, c'est qu'on ne va pas remplacer le métier du développeur, c'est pas l'idée, mais c'est lui donner des capacités supplémentaires et lui faire gagner du temps.
Exactement.
Cool. Bah, du coup, j'espère qu'on se revoit l'année prochaine et que tu nous expliques ce qui s'est passé dans ce beau monde, avec des belles évolutions, j'espère.
Avec plaisir,
Quand
avec
même.
plaisir.
Cool, bah, c'était chouette de t'avoir, Thomas. Merci voilà, de faire partie des sponsors avec Microsoft de ce bel événement. Et j'espère qu'on se retrouve du coup l'année prochaine avec des bonnes nouvelles.
Merci beaucoup. Merci, à bientôt.
À très vite.
Azure Heroes est un programme chez Microsoft qui reconnaît des personnes qui ont un impact dans la communauté. Et donc, que vous soyez contributeur sur des sujets comme la diversité dans la tech, le Green IT, que vous soyez mentor auprès de développeurs, que vous créez du contenu ou animez une communauté, il y a des petits badges que vous pouvez avoir et collectionner avec notre super mascotte ici. Et on a aussi d'autres types de badges. Et je vous invite du coup, pendant le DevDay, à scanner le QR code que vous verrez entre les conférences pour recevoir votre badge Azure Heroes Learner.
Et salut.
Et salut.
Mais t'es pas Renaud, toi?
Mais non, il est où?
Mais
Renaud?
t'es qui?
Renaud?
T'es qui? Tu fais quoi?
Je m'appelle Adrien.
Ah, tu bosses sur le DevDay, toi?
Ouais, j'ai rejoint Renaud.
D'accord. Et tu fais quoi sur le DevDay?
Je suis organisateur.
Ok.
Franchement,
Ok.
c'est cool parce
Ouais,
qu'il y a
ça
une
a
super équipe.
Ça a l'air.
Et j'ai rejoint l'équipe un peu après Renaud, après avoir créé le DevDay. Et là, aujourd'hui, je suis venu l'aider.
Nice.
Et c'est
nice.
super cool parce qu'on a vraiment des speakers de qualité. Ils sont vraiment énormes, dont celui qu'on va venir présenter.
Tu racontes, c'est quoi la deuxième session là?
C'est Guillaume Laforge qui nous vient de l'écosystème Google.
Ok, cool.
Ouais, c'est cool parce que d'habitude, on a toujours l'habitude d'avoir un écosystème qui est fort axé sur Microsoft. Et là, maintenant, on a plein de nouvelles personnes qui viennent nous rejoindre. C'est
Top.
génial. Franchement,
Top.
c'est au summum pour nous.
Bien sûr, évidemment. Et il va
Ouais.
nous parler de quoi?
Il vient nous parler de serverless. Et le serverless, d'après lui, c'est pas une panacée. C'est super simple d'après ce qu'il va nous raconter.
J'aime bien ce titre.
Ouais.
Il est bien. Hein?
Ça a l'air super cool.
Ouais,
Hein.
d'accord.
Ça te dit d'y aller le voir?
Allez, on y va, c'est
C'est parti.
parti. Let's go.
Merci. Thank you, Charlene. Hello, everyone. I'm happy to be here. Thanks for having me, even if remotely. Today, I'd like to tell you about serverless. As a developer advocate for Google Cloud, that's the products, the topic I'm focusing on. So I'm very happy to tell you about this topic today. Serverless is a big buzzword of the day, but is it a real panacea or not? Like Obelix, when I was a small kid, well, I fell in the magic serverless portion a long time ago. When I was working on the Apache Groovy programming language that I co-founded, I started playing with Google App Engine Java in 2009. So before it was actually officially announced by Google at the Google I/O conference. The Google team reached out to me to work with them, to work together in stealth mode, to ensure that alternative JVM languages, like Groovy, would run fine on App Engine for Java. And I wasn't working for Google then, right? But I couldn't really imagine back then that 7 years after that, I would be joining Google, and in particular that I would also work and focus on those serverless technologies. So I'm very happy to be there working on cool technologies and products that I really like. So it wasn't called serverless. That was about platform as a service, as the term serverless wasn't invented yet, although those things are pretty similar concepts actually, as we shall see. But I've been a big fan of serverless, of platform as a service, and in particular of App Engine ever since. So a bit of history after this personal story with Obelix and Google. So let's actually start with a little bit of background and history of how this got started. And this is my slightly funny version of it, of the story. So don't take it too seriously. So at the beginning, humans created the server, right? A machine on which you could run various programs and apps. Well, we also created the internet and the web, of course. Otherwise, we couldn't connect our apps, our web apps, to our users. So if you have a few users, a single server may suffice. But you know how it goes with the spread of the web, the internet. We now have billions of users and millions of servers. And things kind of got complicated, right? And we introduced lots of hard, complicated concepts around distributed microservices, replicated databases with Paxos and Raft consensus and so on. We even coined theorems like the CAP theorem, consistency, availability, partitioning, pick. You can only pick two of those. So it's complicated, right? And humans wanted to abstract away those things, so they invented the cloud in order to not have to deal with the physical world. Well, there are actually still real databases, servers, virtual machines, cables, etc. to manage. However, you don't have to get your hands dirty with those Ethernet cables, changing the failing hard drives, upgrading to the latest CPU and RAM or GPU cards, etc. So usually it's the cloud provider that has folks that wake up in the middle of the night to upgrade those things. That's not you. So you can sleep a little bit better at night, even if your boss may still call you in the middle of the night because your app is misbehaving, but you're really only responsible for how the app is working and not, focusing on the hard drive failures and such. So to focus on the code, to avoid the complexity of managing servers, provisioning clusters, plugging wires, configuring networking, or fine-tuning a database, etc., even in the cloud, humans came up with the concept of serverless. And here's a picture of the latest Google data center for serverless. Look, no servers, right? Well, I'm kidding, of course. There are always servers around, but it's not the same person that's responsible for taking care of the server. Even if the word serverless wasn't there yet, it all started with platform as a service, with things like App Engine and Heroku. The promise was, give us your code, your app, and we'll run it for you. The hardware management aspect were already there. So scaling was also handled by the platform. The pricing was there as well, proportional to the usage of the resources, but we'll come back to the serverless characteristics in a little bit. There's platform as a service, but there's also backend as a service, BaaS. It's pretty similar to PaaS, actually. It comes with batteries included. So you focus on the front end, and all the backend is abstracted away or provided for you. So things like platforms like Parse from Facebook initially and Firebase from Google are two great examples of this. Facebook kind of abandoned Parse into open source land, but Firebase is still there and around and integrates with, and more with various Google Cloud Platform services. So you can have things like static asset hosting, a data store to save your information or your users' information, some kind of runtime environment to run your business logic, and tons of other services like machine learning or for authentication, mobile crash analytics analysis when you're doing mobile applications that reach out to those backends, performance testing, analytics, and more. PaaS BaaS, and FaaS, functions as a service. With the FaaS solution, with the functions as a service, your unit of work, your unit of deployment becomes a small granular function. This concept was popularized by Amazon Lambda. And often, even still today, people tend to confuse FaaS with serverless. But FaaS is really just one facet of the serverless ecosystem, like PaaS or BaaS. So remember that it's not just functions as a service that is serverless, but there are different facets to this. Another interesting facet, another example of serverless is this new approach of a container as a service approach with containerized workloads. So instead of deploying apps or functions, you're deploying container images. You put anything you want inside a container, and that's the approach that Google took with its Cloud Run container service. You don't have the complexity of Kubernetes for running those container images, but you can run your container easily in the cloud in a fully managed environment with all the serverless characteristics that we're going to describe now. Right, so I describe my own take or my own summary of the history that led us to serverless and its various facets, and mentioning some of the products that are there today that you can use today for deploying your serverless workloads. But let's take some time to give a proper definition of what serverless is. For me, serverless is the easiest way to get an idea to production in a minimal amount of time. As a developer, you work on some code and then you deploy it. That's it, really. No infrastructure to manage. Just create a project on the platform and deploy your code. As a developer, that's, paradise. The term itself was coined around 2010 by someone called Ken El-Kabani, who created the pCloud or PyCloud, I don't know how to pronounce it, PyCloud computing platform. So compared to Heroku and App Engine that came a couple of years before that, PyCloud was focusing on different kind of workloads and really not just serving web requests, compared to App Engine and Heroku, which were more like web stacks to serve HTTP traffic. The coachy term serverless came from the fact that they were actually selling a service rather than selling servers or machines or renting VMs to their customers. So it was really why it was serverless. There were no servers being sold or rented. It was more a service that was given to the user. So it's more like software as a service, basically. There are two ways to think about serverless. There's the operational model, where you're using a fully managed environment, fully managed platform with security handle also for you under the hood, with automatic scaling up and down according to spikes in your traffic. It also has a cost model, which is pay as you go. So the more traffic you get, the more you pay, and if traffic decreases, you're going to pay less. So it's not always the same price that you pay. And then there's the programming model. You're going to implement things in a more service-based fashion, building several microservices, communicating together. Your code, your apps are going to be more event-driven, because they are going to react to events in your system, in your architecture. And you should also program in a more stateless fashion, in the sense that you're never quite sure which instance is going to get the next request. So you can't rely on things that would have been done or data that would have been cached beforehand on another instance. Operational model and programming model. So let's give some more. Let's zoom in. Let's focus on those concepts a little bit more. There's no so fully managed and automatic scaling. There's no provisioning of clusters, servers, instances, VMs, etc., or anything. It's all handled by the platform for you. So you just give your code, your app, your function, your container. It's a fully managed environment, and things like security patches are applied automatically to the underlying operating system or libraries that are being used. So if you remember the Spectre and Meltdown things that happened recently, they've been mitigated transparently and rapidly for customers on Google Cloud. There were no wake-up calls in the middle of the night because the cloud provider under the hood took care of patching the kernels, etc., so that users and customers wouldn't be affected. So your apps will also scale automatically from 0 to 1 instance, 1 to n instances if there's a big spike of traffic, and down from n down to 1, as well as back to 0 if there's no traffic at all. So for example, you may have a monthly report, so you have a big spike in traffic once per month, 1 day per month, and otherwise the rest is idle. Basically nothing happens, so you scale down back to 0. You're doing so by tracking things like CPU load, well, not you, but the platform. Tracking CPU load, memory usage, the number of incoming requests, the number of in-flight requests, and with some magic formula, serverless platforms are able to scale up and down your services without you having to worry about this. And the cloud provider, again, takes care of that. In terms of pricing, it's a pay-as-you-go cost model. So it actually goes hand in hand with automatic scaling. So if there's no traffic, you pay 0. But if there's twice more traffic than usual, you pay proportionally to that amount of traffic. So if the load goes back to 0, the instances are freed, are decommissioned, and again, you pay 0 for capacity that you're not using. So it goes hand in hand with automatic scaling. Now on to the programming model. More and more we're transitioning from building big monolith into orchestrating smaller services or microservices. So it has its challenges though, right? But with smaller services, your teams can develop them more independently and scale them differently potentially, or even deploy them with different life cycles. Since you have some more loosely coupled services, they tend to react to incoming events from your system or from the cloud. For example, a notification of a new file in cloud storage, a new line in a reactive data store like Cloud Firestore, a message in a message bus like PubSub. So your services usually communicate asynchronously to stay properly decoupled. But the more asynchronous your services are, of course, the harder things are to operate and monitor, observe, etc. when business logic spans several services. So you have to figure out what's the current status of that workflow across your services. Another important aspect is the fact that services can scale up and down and back to 0. Is that there's no guarantee that you're going to hit the same server all the time. So if you can be certain with that some data that would be cached is still there. So if you, well, sorry, you can't be certain that some data that would be cached is still there, because you know, a request could hit a different server than the previous server. So you have to program defensively to ensure that any fresh instance of your app is able to cope with any incoming requests. So state is really it's pretty much the enemy of scaling. So the more stateless you can be, the better it is. We've been speaking mostly about serverless compute. That's really the focus of this presentation, but I wanted to mention that serverless is not just about compute. So you could consider that anything that is fully managed, that offers pay-as-you-go cost model, pricing model, that is a service in the cloud, so pretty much like most SaaS service in the cloud, is also serverless. So you don't have, because you don't have to worry about the infrastructure, about managing servers, about scaling those things. There are great examples of things that are serverless beyond compute in Google Cloud. For example, I'd like to mention the BigQuery platform, which is a fully managed serverless data warehouse and analytics platform. You pay proportionally to the amount of data your queries are going through. So it's not about paying for the storage or paying for the running servers that do the query calculations, but it's really about the data you're going through. So it's like incoming requests for a compute platform. Here it's data you go through for your queries. So there are plenty of things that are serverless, things like machine learning models or data stores, databases like Firestore, etc. There are many things that are fully managed services that we can say they are serverless. All right, so after those definitions, etc., let's focus a little bit on the challenges. So serverless sounds pretty cool, right? But there are certain challenges. And compared to running a good old big monolith on an on-premise server, there are challenges. So we've already given some hints of some of them, but in particular now I'd like to spend some time on telling you about 4 key aspects. The lock-in factor when you're tied to a particular platform because of the dependencies. The infamous cold start, because as you scale down to 0, you have to restart or respawn, reinstantiate your services. Cost controls as well. Scaling up and down, that's great. Paying less is great, but sometimes if you've got a peak of traffic, you'd better be in control of the cost you are ready, to spend. And the last thing I'd like to cover is the complexity, the mess of what I call spaghetti microservices. The platform as a service solutions, the backend as a service solutions usually come with batteries included. They have built-in APIs for databases, for communication, for lots of things. It's super convenient for developers. As a developer, you're much more productive because you don't have to make a choice. To wire things up, to configure third-party services, etc. The choice is actually already made for you. But I'm seeing those batteries more and more being externalized as their own standalone product. So for example, again, on Google Cloud, because that's where I'm working, Google Cloud has externalized things like its NoSQL data store or its PubSub messaging hub, its scheduler, its task handling capabilities. Before, those services were actually part of the platform as a service. But however great having built-in batteries, powerful batteries is, often these are proprietary or specific to that platform. So there's you end up being locked to the platform you're building upon. It can be a choice. It's the choice of productivity in a way. As long as you're aware of it, that's fine. But it's a trade-off between portability and time to market, right? So you might still be tied to those products, but well, if they are externalized, it's easier to switch to something else. But at least you can move the business logic around as well if those services are externalized. Because the code is more portable then, because there's less adherence. And you can create a level of indirection as well between those, let's say, data services. You create a data layer to be able to abstract away those dependencies in case at some point you want to pick up a new, a different data store, database, etc. A common issue you hear about in serverless land is the infamous cold start. Winter is coming, so cold starts as well. Since you can scale to 0, otherwise it's not serverless. It means there's currently at that point no server, no instance or clone or whatever it's called to serve an incoming request. So what happens? The cloud provider has to reinitialize, instantiate, rehydrate some kind of server, VM, or container to serve your application. Additionally, the underlying language runtime that is being used, so let's say I write a Java function or a Java app, the JVM, the Java Virtual Machine, has to start up as well. So that's an extra time. The time for the platform to be ready, the time for your runtime to be ready, and on top of that, there's your app that also needs to start up. So you'd better try to optimize at least the time your app needs to be ready to serve the first request, because that's the part you're in control of. But you'd also like to be able to control the underlying infrastructure in a way. There are workarounds or hacks, I would say, like pinging your server at a regular interval of time to keep it warm. But it's a bit of a hack in the sense that, or even an anti-pattern in the sense that you potentially pay for idle capacity that's sitting doing nothing. So it's like having a server running all the time, which is not serverless, right? So some platforms actually provide some knobs that you can play with, that you can tweak, like provisioned instances or minimum instances, and usually at a lower price, which is great. So for instance, if you're using Cloud Functions or Cloud Run on Google, you can specify that you want a certain minimum number of instances that are ready and warm to serve your apps, and that are also usually cheaper. So that way, you lower the time needed, because you completely eliminate the underlying hardware, VM, hypervisor, etc. Startup time. It's eliminated because the instances are warm. Then your runtime, let's say like the JVM, should be also ready to run, and your app as well. So you eliminate the cold start that way, or most of the cold starts, because when you've got big spikes of traffic, at some point you will still get some cold starts because there are new instances that are coming up, or you may be getting some latency on the warm instances before a new instance is ready to serve the extra load in terms of traffic. So speaking of extra load, when I mentioned the minimum number of instances, you could also think about a maximum number of instances. It's actually an important idea, because when the platform auto scales transparently to handle the increased traffic, to spin up as many instances as needed to serve the incoming request, it also means that there's increased costs, because the more servers, the more instances serving your traffic, the more it costs, right? So in order to bound your budget to a known quantity, you want to put a limit, a top limit, rather than burning your money with all your hot instances. You can cap the number of instances that will serve your application, your content. The service may be a bit degraded with, when you reach that limit, the latency will likely increase, but at least your budget doesn't go through the roof. There's a cap on that budget, so you won't be spending more than X dollars or euros. That's why Google Cloud Platform introduced that notion of capping the number of instances running of functions and apps and containers in its serverless products to have more visibility, more control around costs. The last challenge I'd like to mention, that's the spaghetti microservices. So it's so easy to write functions and services in a serverless platform that you tend to write too many of them, perhaps, with a very small granularity. So you want one service to do one thing and to do it well without tight coupling to other services. But after a while, you end up having perhaps too many microservices to handle and manage. That becomes a big mess, a big spaghetti of microservices. So it becomes very complicated to know which service invokes which other service, or what are the dependencies between the services, or how they react when one goes down and the others are up, etc. So there are many patterns like circuit breaker patterns and service meshes and so on. But it really becomes very complicated to see what, or complicated to monitor, to observe, to really figure out what's happening when one microservices fail, and how it impacts the rest of your architecture, and how it ruins your clockwork architecture. And monolith on that bad, actually. So I'm not advocating for going back to big balls of monolith, but really don't start right away with writing the smallest unit of work possible, but really pay attention to how you split the big monolith into microservices, where are the bounds, the bounded context and so on. So otherwise you'll end up with a big plate of spaghetti that is hard to handle. There are very good articles, very good presentations on this topic on how to split a big monolith, but it's really beyond the scope of this presentation, and there's no simple rule of thumb answer to that question. So be sure to have a look at the literature on that topic, which is very important. So I'd like to conclude with this third part on what the future holds for serverless. What are the highlights? For me, there are 5 key aspects. First of all, open and openness, as in open source, open standards, open platforms. Containers, we'll hear more and more about containers, in the sense that it's easier to put something in a box rather than relying on particular versions of a runtime, etc. We'll be talking about glue, glue services that bind things and microservices, your services together. We'll be talking about the edge, so not the guitarist from YouTube, but the edge networking, how serverless is moving away, not away, but in addition to being inside big data centers, how it moves outside to the edge of the network, as close as possible to the end users, to reduce latency, etc. And the 5th element I'd like to cover is, perhaps it's more futuristic, but machine learning. How machine learning can be applied to serverless platforms. So let's start. So let's start with open source, open standards, etc. So we want to avoid locking because we may be tied to a particular platform, but at some point we may decide to move to a better, more modern platform or something like this. So we want more portability for our applications. For instance, the platforms they actually rely on open source software for sure themselves. But the platforms, well, they can be open source too. But if you look at some platforms like, let's say, Google Cloud Run, it's even actually based on an open source bricks and on the Knative open source Kubernetes platform. So it's a kind of API and contract that cloud providers or platforms that you can even run on premises. It's the same kind of contract that tie those platforms together, meaning that you can take your containerized workloads and run them on other platforms that are compatible with this Knative standard or open platform. So as long as, let's say, you've got a Kubernetes cluster that you're running in your data center, for example, you can install or have your Kubernetes cluster be compliant with the Knative standard. So you're not locked to Google Cloud or another cloud when you're using something like Cloud Run on Google. You can move your workload, your app on a Knative compatible platform from another cloud provider, or even on premises in your infra. Another example of this openness aspect is, for example, I worked on the new Java runtime for Google Cloud Functions. It's actually a runtime that is available as open source. So you can deploy your functions in Google Cloud Functions in the cloud, but you can also run your functions elsewhere too, in a hybrid cloud scenario on your own machine, or when I say your own machine, I mean even your development machine on your laptop. And it also increases and improves your development feedback loop, because you can run your function the same way it's going to run in the cloud, but you can run that on your machine. So it's great for portability, but also for improved developer experience. The third thing I'd like to mention about this openness aspect is also the way you build or deploy those sources to the cloud. This aspect can also be more open. And for instance, Heroku, who's the creator of build-packs, and Cloud Foundry also worked on this with them later on. But more recently, Heroku and Google Cloud partnered together on the new version of build-pack called Cloud Native build-packs. So it's a way of building your sources, the sources of your application, into container images. So you're containerizing your apps so that they can run on any cloud that can run containers. So really, it's all about portability and avoiding locking by favoring open source, open standards, open platforms to make things as open as possible. As I was mentioning Cloud Native build packs, the fact it builds on portable containers for your app source code. So notice here that we're speaking about containers, right? And why containers, you may ask? Well, with things like platform functions as a service, you are pushing apps on the platform runtime, but you may be limited in terms of the choice of the language runtime. Perhaps you've got the choice between 3 or 4 languages or more, but that's all. Or you cannot necessarily use all the libraries or binary dependencies that you want, but that you would like to bundle in your application, or that your application depends on. So if you made the choice of using some kind of esoteric programming language, or you need some special software installed, perhaps you won't be able to run your app on those BAS or PaaS solutions. So instead, if you could put everything you need in a box, in a container image, and if the cloud could just run that box for you, then you can do pretty much anything. That's why we are using containers more and more. You can also run those containers locally on your machine for increased and improved developer experience. And that's also why at Google we released Google Cloud Run to run your containers. but serverlessly, with all the serverless characteristics we've already mentioned about the operational and programming models. But you can run them serverlessly with any runtime, library, language that you want without limitations. So I'm seeing more containers in the future for more portability. You remember my big plate of spaghettis? So to orchestrate your services, to create those business workflows, to observe and monitor them, to track that they are communicating properly, asynchronously. You'll need more tools to ensure that it all runs fine in the cloud. So that's why I'm seeing more tools like Google Cloud Tasks, Cloud Scheduler, Cloud Workflows, or in the Azure and AWS worlds, you have things like Logic App, step functions, etc. To coordinate things, you'll need message buses, message hubs, like Cloud Pub Subs, like Amazon SQS, like Azure Service Bus, etc. You'll need all those infrastructure tools and services to bind things together. In the Kubernetes world, we've also seen service meshes emerge as a key architectural pattern for that same purpose. So maybe a monolith is simpler to develop and operate, but as you move towards more of a microservices-based architecture, you'll need more of those glue services to track how things are going, to implement circuit breakers, to do guaranteed delivery of messages, to do retries with exponential backups if a service is failing, and on all those kind of patterns. So you'll need more glue to tie everything together. The other, my fourth point I'd like to make here is serverless is not deep in the data center, but it's moving also to the edge of the network. Recently, Cloudflare released a product called Cloudflare Workers. So it's using the V8 JavaScript engine, and it isolates concept to run your functions in a sandboxed manner. There are two very interesting aspects to me in this new product. First of all, that's the idea that of having your serverless functions run at the edge of the network. So not deep inside the data center, right? Instead, those functions are as close to the users as possible. So the latency is also reduced and is really minimal. Secondly, to further reduce latency, avoid cold starts, there's really a great hack, a great innovation that almost eliminates completely cold starts. So Cloudflare Workers being just JavaScript bits of code or WebAssembly bits of code, it's super fast to start already, but they further thought about it, how to eliminate cold start. So normally when there's an incoming request to a function, sorry, you have the web stack has to do the HTTPS SSL handshake before routing the actual code to a function. But the trick is that they know that this particular URL is going to be a function. So as soon as the SSL handshake starts, and it's an operation that takes several milliseconds, as soon as the SSL handshake work starts, they are actually already starting to spin up a new isolate to serve that first request. So before the end of the HTTPS SSL handshake, the cold start is eliminated because the JavaScript isolates are already ready to serve your first request. So that's a really great optimization and a very creative way when you really control all this stack. So that's great innovation. I'm really thinking that we'll be seeing more of such innovations and also moving stuff towards the edge of the cloud infrastructure and as close as possible to the end users, rather than deep inside the data center. And the last thing, lastly, I'd like to look into the future. And I'm curious to see how machine learning is going to play a role in the serverless offering of cloud providers. So in particular, you still have to specify VM instance sizes or specifying a memory or CPU requirement. Some would say it's not very serverless since there are servers involved somehow, although servers are supposed to be abstracted away by serverless. But in Google Cloud, for example, we have what we call a clone scheduler that is responsible for creating a new instance of your function, apps, etc., depending on various factors, CPU load, memory usage, number of in-flight requests or incoming queries, etc. So there's some magic formula that is computed and calculated that figures out how and when to spin up a new instance to serve more traffic. But Google recently, last year or 2 years ago, recently fully automated data centers thanks to machine learning. So instead of having operators that tweak tons of knobs, it's machine learning algorithms that are able to tweak the power usage efficiency knobs of a data center and to really reduce power consumption by up to 40%. So it's even greener, of course. And I can imagine a future where machine learning is used to further upsize or downscale the underlying machines, running your serverless code and provisioning the right amount of resources to reduce latency, CPU usage, etc. So let's see what the future holds for serverless, but it's very promising, and I have the intuition that machine learning is going to play a bigger role in this serverless picture. So that's about it. Thanks a lot for your attention. Thanks for having me, and even if remotely again. So I'm looking forward to seeing what you're going to build next on a serverless platform. Thanks for having me, and stay safe.
Bon alors Adrien, t'en as pensé quoi de la session? Tu retiens quoi?
C'était génial. Franchement, il a super bien présenté ça. Ça me donne envie de regarder ce qui se passe chez Google. Parce que j'ai plus l'habitude, moi, en tant que Microsoft MVP, de rester dans l'écosphère Microsoft. Ouais. Et ça me donne vraiment une ouverture d'horizon qui me donne envie d'aller voir ce qui se passe là-bas. Et la façon dans laquelle il a présenté ça, ça m'a vraiment envie de pouvoir continuer à cette partie-là.
Et justement, si tu veux continuer à le suivre, il y a un podcast, il me semble.
Il est sur un podcast qui s'appelle Les Cascodeurs. On va mettre le lien juste en dessous pour pouvoir aller le voir. Et franchement, ça vaut la peine d'aller le suivre.
Cool, excellent. Et ben, si on continue avec les podcasts aussi, rappel pour tout le monde. Là, on sent que c'est en train de...
Il y a une émulsion, il y a quelque chose qui se passe.
Il y a un truc qui se passe là. Ça se passe sur Twitter, ça se passe sur Facebook. Le compte Twitter DevDay, pareil pour Facebook. Ouais. On met tous les liens s'il le faut. Ils apparaissent partout, là, ici, là. Les explosions.
Et sur Discord.
Et sur Discord, bien évidemment. Numéro 1, c'est clair.
Par contre, il ne faut pas qu'ils oublient, c'est de nous envoyer une photo de leur installation.
Ah, moi, je veux voir des photos d'installation.
Moi aussi, personnellement, j'ai vraiment envie de voir comment ils sont installés.
Bien évidemment, parce que nous, là, on est dans ce décor complètement surréaliste.
C'est ça, futuriste.
Et ça se trouve, on va être surpris, hein, parce qu'il y a peut-être des auditeurs, des auditrices qui nous regardent et qui ont mieux que nous. C'est pas impossible. C'est pas impossible. Bon, vous savez nous retrouver en tout cas. Voilà. Réseaux sociaux, échanger avec nous. On est juste là derrière. Ce serait vraiment cool. Ouais. À tout de suite.
À tout de suite.
Salut Olivier.
Bonjour Charline.
Comment ça va?
Ça va et toi?
Nickel. On est très content que tu sois là. Surtout parce que tu représentes l'ISIT et tu représentes un magnifique projet qui est derrière tout ça. Alors l'ISIT, c'est des lettres, mais c'est quoi surtout? Ça veut dire quoi ISIT?
Alors ISIT, c'est Institute for Sustainable IT ou Belgian Institute for Sustainable IT, puisqu'il y en a 3. Il y en a un en Belgique, il y en a un en France et il y en a un en Suisse. Et donc on est un ensemble d'instituts qui voulons aider à réduire l'empreinte environnementale du numérique.
Et toi, tu fais quoi l'ISIT?
Je suis le directeur.
Excusez-moi, monsieur. Excusez-moi. Et du coup, c'est quoi les priorités justement qui sont mises en avant par l'ISIT? C'est les priorités ou les grands objectifs, ça ressemble à quoi? Pour nous expliquer.
On a 3 axes de travail. On a d'abord le Green IT, donc c'est la réduction de l'empreinte environnementale de l'informatique. On a l'IT for Green, c'est l'utilisation de l'IT pour réduire l'empreinte environnementale dans d'autres domaines, l'énergie, la gestion des bâtiments, des choses comme ça. Et puis, on a tout ce qui est aspects sociétaux, par exemple les conditions de travail, les travailleurs du clic, l'extraction des matières premières dans les mines, le travail dans les usines, l'intégration des personnes en situation de handicap, la réduction de la fracture numérique, etc.
J'imagine que tout ça, ça résonne particulièrement avec l'actualité. Enfin, là, tout ce que tu viens de dire, on l'a vu sur certains articles quand on scrollait sur notre téléphone. Évidemment, ça bouleverse notre société. Comment tu le vois aujourd'hui? C'est quoi qui te choque là avec l'actu en ce moment?
Alors déjà, avant la crise du Covid, il y avait toute la question de l'empreinte environnementale, le carbone, etc. Et donc, effectivement, l'IT émet environ 4% des émissions de gaz à effet de serre de l'humanité. Donc, on est au même niveau que l'aviation civile avant la crise du Covid. Et puis maintenant, tout le monde est connecté. Oui. Donc, il y a justement tous ces aspects, principalement d'utilisation de Netflix en beaucoup plus grande quantité. C'est un des aspects qui a le plus évolué avec le confinement, beaucoup plus que le télétravail, qui ne change pas tellement l'empreinte carbone global, puisqu'on voyage beaucoup moins, on doit beaucoup moins aller au bureau, des choses comme ça. Et donc là, on a plus une compensation. Là où il y a une vraie augmentation, c'est par exemple les vidéos.
Exactement. Et là, avec l'actualité côté Europe aussi, tu remarques du coup, genre, évidemment, la relance, le grand plan de relance, on entend parler, quoi. Ouais. Et est-ce qu'on parle un petit peu de green dedans, ou c'est dedans, ou c'est pas du tout dedans?
On en parle beaucoup, on parle du Green Deal. En fait, le Green Deal, c'est justement relancer, il y a 750 milliards qui sont mis à disposition pour relancer l'économie européenne, et dans ces 750 milliards, il y a 57% qui sont prévus pour des aspects liés au Green IT ou à l'IT for Green. C'est énorme. Et donc, c'est vraiment une chance pour les entreprises européennes et belges en particulier, mais pour les entreprises européennes, c'est une possibilité réellement de faire une transformation digitale et environnementale en même temps.
Okay. Et du coup, pour toi, là, tu remarques que ça va changer aussi la vie des gens comme toi et moi. Si tu avais des astuces, parce qu'on sait que le changement, ça prend du temps pour s'installer, les premières choses déjà qu'on peut actionner, nous, des personnes lambda comme toi et moi, qu'est-ce qu'on peut faire?
Alors à la maison, tout simplement, d'abord les équipements. Essayer d'en acheter moins, les garder plus longtemps et leur donner une deuxième vie si on ne les utilise plus, ou acheter du reconditionné, c'est aussi une très bonne option. Donc ça, c'est vraiment le principal. Deuxièmement, ça va être les vidéos. Dans les usages, c'est clairement les vidéos qui ont le plus d'impact, en particulier les Netflix, YouTube, etc. Tout ce qui est streaming, essayer de diminuer la définition des images qu'on va prendre. Potentiellement, si on va regarder plusieurs fois la même chose, le télécharger une seule fois plutôt que de le streamer à chaque fois, tout simplement. Donc là, on est sur la réduction des données. Et puis pour la façon de transférer les données, ça va être d'utiliser le Wi-Fi plutôt que la 4G. Yes. La 4G consomme 3 fois plus que le Wi-Fi.
Ok, moi j'ai tout noté là, je l'intègre dès demain. C'est vrai qu'on est tous responsables acteurs là-dessus, donc autant qu'on commence. Hein. Mais alors du coup, là, nous imaginons, on intègre ça dans notre quotidien, soit, et le professionnel. Oui. Qu'est-ce que ça change pour lui?
Mais pour le professionnel, un développeur sera toujours un développeur, un ingénieur système, simplement avec une corde additionnelle à leur arc qui va être de comprendre l'impact de leurs actions professionnelles et d'utiliser justement leur boulot pour réduire l'impact qu'ils peuvent avoir sur leurs clients en fait. Donc l'effet levier qu'on a à travers le boulot est nettement supérieur à ce qu'on peut avoir en personnel finalement. Et donc effectivement, dans chacun des métiers de l'IT, on va avoir la possibilité de jouer sur la façon dont on fait son travail pour réduire son empreinte.
Moi, j'aime bien quand tu dis que c'est une nouvelle corde à son arc. Je pense que c'est exactement ce qu'il faut retenir, tous acteurs du sujet. Et merci d'avoir été là. C'est super cool. Et j'espère qu'on te revoit du coup l'année prochaine, Olivier.
Avec plaisir. Merci à vous.
Ça marche. À très vite.
À bientôt.
Bon, Adrien.
Ouais.
Tu m'as menti, en fait.
Non. Qu'est-ce que j'ai fait?
Écoute, moi je vois DevDays, l'événement des devs pour les devs.
Ouais, c'est
et là,
ça.
j'entends dire, on m'a dit dans l'oreillette là à l'instant qu'il y avait un pilote d'avion qui arrivait.
Exactement.
Et normal?
Ben oui, le DevDay voulait faire ses ailes. On voulait notre petit badge capitaine.
C'est bien. Et tu nous fais voyager.
Exactement.
Pour la dernière station, c'est intelligent ça.
Oui, parce que c'est la dernière, malheureusement. On arrive déjà à la fin de notre soirée Keynote.
Ah oui, et qui nous emmène alors?
Alors c'est Clifford, c'est le capitaine Clifford Agius.
Très bien. Et alors, il va nous parler de quoi?
Alors, il va venir nous parler du Pilot Decision Management.
Ok, c'est-à-dire?
Il va nous expliquer comment les pilotes, lorsqu'il y a un problème avec un avion, réagissent. Et comment, lui, et c'est là où je ne t'ai pas réellement menti, il est en fait développeur freelance sur le côté. Donc, quand il est au sol, ou peut-être dans les airs, on ne sait pas, c'est pas notre problème. Mais
Pas savoir.
voilà, exactement. Mais lorsqu'il est au sol, il développe, il a sa société en tant que freelance.
Classe.
Et il est Microsoft MVP aussi.
En plus.
Ouais.
Donc là, tu nous as réservé un petit bijou pour la fin.
Exactement.
Merci.
On termine en beauté, vraiment au summum,
Bravo le
dans les
DevDay.
airs, au 7e zèle.
Ouais, bravo, vous êtes fort. Allez,
Ouais.
on lance. Let's
C'est
go.
parti.
À toutes.
À toutes.
Hello everyone, my name's Clifford Agius and I'm a senior first officer flying Boeing 787s around the world, commercial aircraft, passengers and cargo. I'm here today to give you a talk about critical decision-making skills. It's how us pilots, when we're flying at 600 miles an hour, make decisions when things are not quite right. So I'm going to talk to you about that and a bit about me first. As I say, I'm an airline pilot for a major UK airline. When I'm not flying jets around the world, I work as a freelance .NET developer, working with electronics, IoT mostly, but also Xamarin Space and C#. I love learning new things and cycling and spending time with family. But really, you're here to talk about decision-making skills, and that's the office. That's the flight deck of a Boeing 787. -8 aircraft. This is one of the first aircraft that we got in our airline, and I got to deliver this one from Boeing Fields in Seattle, and the list price on the bit of paper said 250 million. I'm pretty certain that's not the cost that the airline paid, but that is just a bare bones aircraft. So without the seats you sit on, the toilets you use, the galley that the food's prepared in, the IFE, in-flight entertainment system that you use to watch the movies, etc. So, you know, they are expensive bits of kit, but they let me fly around the world, which is fantastic. If you look just at the top here, where my mouse pointer is, you can see we have head-up displays on the 787. It allows us to make approaches in poor weather, so foggy conditions. I'm currently sitting in London. And it's very foggy out my office window at the moment, so it'll be getting used quite a bit today. But also we have some big 15-inch flat panels LCD screens that all our avionics and systems are on board this 787. The office view. So I just said the office view outside my office where I'm sitting now is currently foggy, and I can't quite see across the road. It's quite thick. But the office view, the view of the 787, as you can see on the left, is a wonderful view and picture, not taken by me. This is one I found on the internet on airliners.net. And that's of St Elmo's Fire. It's sometimes called different things, but it's what we call it. And that is where you get static electricity and statically charged air passing over the aircraft when you're traveling too close to a storm. Electrically charged storm, and you get this kind of lightning effect that goes across the windscreen, and it gives you that, as you can see in the windscreen there in front of the two pilots, that lightning effect, which is, you know, looks really pretty. Oh, look at that, that's great, it's fantastic. And then you realize you're about to be struck by lightning, because it typically follows a minute or two later. You can see, you can just about make out on the image here on the ND navigation display, you can see these patches of green, amber and red. That's the weather radar picking up the storm returns. And obviously, you know, we wouldn't fly anywhere near a storm typically, but sometimes, you know, you have to pass through a storm line just to get to where you're going. So we try and avoid it. And if we see St Elmo's Fire, we try and get away from Dodge as quick as we can. But sometimes you can't avoid it. On the right-hand side, though, that's the view through the head-up display I mentioned a few moments ago. And you can see there we're cruising at 31,000 feet, altimeter tape, and we're doing 287 knots, and which is Mach decimal 78, 78% speed of sound at sea level. And we're flying along, returning home from the US. I took this picture many moons ago. You can see we've been tracing these two contrails, these two aircraft. And the 787 flies quite quickly normally. I mean, slowed up a little here by London, but we took an early descent due turbulence, and we got below these two aircraft that were in front of us that we've been chasing most of the night across the Atlantic and catching up quite quickly. But the problem is, because we're then below them, they can't descend because we've blocked that airspace, because we take control of the airspace there around us, have a 5-mile bubble around us and a 1,000-foot separation above and below, which meant they couldn't descend. So we got to make the approach into home base nice and early in London, which meant, yeah, we were first to the car park and first to go home. So not that it's a race, but, you know, first one there wins. But there's some of the fantastic office views that we get outside our office window, which is a bit different, as I say, to the foggy day outside my window today. Some interesting facts about the 787. Total electrical onboard power is 1.45 megawatts, so 5 times more than conventional airliner, enough to power, you know, quite a few homes. It's a lot of power. I always think of Back to the Future and I've forgotten his name now, the mad scientist, how many gigawatts of power, when he's talking about lightning bolt, when I mentioned this in the slide deck. The Lockheed Martin Orion spacecraft is supposed to be going to space next year. Its flight deck is derived from the 787. It's got the same screens. It's a very similar layout, I'm told. I've sent a letter to NASA to ask them to let me have a go. We'll see what happens. If anyone's been on a 787, you'll notice the passenger windows are huge. You know, 30% larger, and you know, the most similarly sized aircraft, at least double that of a small Airbus A320 or 737 aircraft that you may be whizzing around Europe on. They're quite big and they dim as well. So you, rather than having a slider that comes down and closes the window like a blind, these are dimmable windows, which means the cabin crew can control the whole cabin and put the windows to full bright or dark as needed. As I say, we typically fly along at Mach 8.5, 650 miles an hour, give or take a bit of wind, head or tailwinds. They do go faster. I've flown it up to Mach 9.0 to meet an oceanic entry time. So yeah, quite quick jets. You know, one of the fastest in the sky at the moment, other than biz jets, obviously, which do go considerably faster. And the 787, if you've ever been on a 787, you'll notice that they ride out turbulence really, really well. The wings kind of flap like a bird. If you look out, if you ever get the opportunity to fly on a 787, highly recommend sitting where you can see the wingtip on takeoff and landing, because you'll see it flexes up quite a bit. And that kind of wind flex technology allows it to ride out turbulence. And the computers are very, very clever. The nose of the aircraft is 2 angle of attack vanes that provide information for our avionics. They sense turbulence. So if one's kind of pointing up and down really quickly, it's sensing turbulence around the nose of the aircraft. It can then make some critical decisions for itself and send that data to the elevator and the ailerons, which are at the tail and on the wings, and ride out the turbulence. So it can adjust in those milliseconds. It can decide what's happening to the aircraft at the nose, make a decision to change the angle of attack of the aircraft. By the time that turbulence has reached the wings or the empennage, the tail of the aircraft. So it's quite quick. So there's over 1,000 computers on a 787. We stopped counting when I spoke to the engineering team at work and also the burn engineers. We stopped counting when we got to 1,000. So there's over 1,000 computers, all making trillions of decisions every second. But the important part is, all they do is provide us, the humans, with information. It's us, the humans, the warm fleshy bits that sit at the front on the flight deck, that make the critical decisions, that decide what to do. All the computers are doing is providing information. So if we watch this short video. It's shot by Simon Lowe. It's on YouTube, if you wish to look it up. There's Flappy Bird. Flappy Bird goes down the wing and is no longer a bird.
Mountain 263 Hotel, Roger. All runways available for landing. Temperature wind 0 to 2 degrees at 5 knots.
I love the at the end. Now, do you think when those guys got up that morning and were about to take their flight down to Tenerife, sit on the beach and have a nice cold beer and relax in the sun before, 2 or 3 days later flying home, do you think when they got up and ate their cornflakes, they left the house, kissed the kids goodbye, said goodbye to the wife, and went off to work? Do you think they were going to experience that day today? They've got, best part of 15,000 hours, how many thousands of flights I've done over my kind of years of flying commercially. I've never had an engine failure. I've had an engine surge, not quite as dramatic as that, but it's not something you plan, not something you think about when you're driving to work, and you get there and you start your working day. You don't expect to have to make a critical decision that could be, in our case, life or death. If you work in IT, it could be the fact that you've just bought Amazon.com down, and suddenly millions of pounds are not being made on Black Friday, for example. Whatever it is you do in your day-to-day job, there's going to be sometimes critical decisions where someone's going to throw you a curveball. So we just watch that again. We'll talk through it a bit more. So you can see they're taking off down the runway. Just at the point of rotate, just getting airborne, Flappy Bird goes down the wings. Engine is now surging, which is basically a backfiring engine, just like a car backfiring. They fly the aircraft, so they do the critical part. So they're flying the plane, the gear's going up.
Mountain 26 clear tower, roger. All runways available for landing, temperature wind 0 to 10 degrees at 5 knots.
So like I say, they aviated, so they flew the aircraft, because that's the important part, and they did their critical drills they have to do. They made sure they knew where they were going, so they talked about the fact they're going to turn inbound towards Wallasey, which is just at Liverpool there in the UK. And then they told air traffic control what their intentions were. Air traffic control come back nice and calm. You can see, this is a pretty big emergency. Fire trucks have been coming out. It's made the news, etc. that day. But it's all calm and collected because we trained for these emergencies. They then continued. They went and dumped some fuel to get below the max landing weight, and they come back and landed some 20-30 minutes later. Aircraft went off to maintenance, and engine got changed, and all was well. So, as I say, that wasn't what they was expecting to do when they got up that morning. It wasn't what they was expecting to see. How about these two? Do you remember these? Do you remember the Miracle on the Hudson? It's been made into a Hollywood movie now, which I highly recommend. It's highly accurate. It's a really good movie, and explains a bit more detail than what I'm going to go to here. But they had a bird strike, a load of geese, and then 4 minutes later they land on the Hudson. There was no other option. If you watch the movie, you'll see in detail. There's no other options that they had. And again, the crew on board that day, had not woken up that morning, had not gone to work, planning to have to land on the icy cold Hudson River. How about the one at the bottom, the British Airways 038 incident, the land at Heathrow on the grass? They've flown back from Beijing. They've been up for like 12, 13 hours. So, quite tired, quite jaded, expecting to land, taxi into the terminal building, jump in their car and go home to their family. But no, 30 seconds from landing, the engine didn't spool up to the approach idle power setting, and they descended below the glide path and landing short. Now, just as you can see this this car at the base here, and you can see the ILS instrument landing system antenna here. Just off the bottom of this picture is the A4, which is quite a major road going past London Heathrow Airport. Just the other side of that major road is Hatton Cross, London Underground Station, and also a big BP petrol garage. Now imagine if they'd landed, 100 meters shorter than where they did land. They landed on a petrol garage, a packed London Underground Station, with commuters going into London. So, the decisions that were made on that day by the crew was to reduce the flaps and carry out an emergency procedure, which got them to clear the petrol garage, clear the underground station, and land just short on the grass. They didn't quite make the runway, but they averted a major disaster. Captain Slellenberger and crew, rather than putting the aircraft into Central Park or trying to make it back to a runway where they knew they weren't going to make it, they picked the big blue runway. All right, it's a bit wet, but they picked the big blue runway and landed in Hudson and saved everyone's life. So both these instances, the crew had to make critical decisions with just seconds to do, and in doing so, averted disaster. The aircraft are broken, but everyone walked away, and that is what we're to talk about. Now, the first thing we need to talk about is the human factors, how it affects us as humans. Now, if there's an input to us as humans, we've got the kind of caveman-esque chimp that sits inside us, and then we've got the human element, a big brain that sits up here. Now, the caveman-esque chimp response is your fight or flight response. So if there's a loud bang next to you, you know, something crashes next to you, you jump. You know, a car backfires, you jump. You know, you're driving along the road, and a child runs out in front of your car while you're driving, you know, or anyone for that matter. You instantly just hit the brakes. You don't need to think about it. You're just, you know, your brain just kicks in there and just does the actions it needs to do. That is a chimp response. That is your fight or flight. That is your humanistic, caveman-esque, you know, response. And the second human response is a bit where your brain kicks in and starts to think it through. Oh, you know, there's a child running in front of me. Oh, I better, you know, push the brake pedal. I need to lift my right leg off the accelerator and push it on the middle pedal, which is the brakes. I need to push quite hard, so I'm getting quite close. Your brain's gone through all of that really, really quickly because the chimp's taken over. And the problem is you need to be careful because, you know, if you don't have a lot of time, then the chimp, your naturalistic chimp response takes over and carries out the actions. If you've got a lot of time, you can be analytical. So you can think through, you know, the issue that you're facing and deal with the issue. And then in the middle is a rule-based response, and we'll come back to that in a wee while as to what that is. But if we talk about the naturalistic, this is your pattern matching. You've seen a child run in front of you, I'm going to hit the brake, you just do it. For me, an engine surge after takeoff, I train every 6 months. I go into the simulator and spend 2 days in the simulator, and we practice emergency drills. So for me, I know exactly what to do if I get an engine surge. I'm going to turn the auto throttle switch to cut off. I'm going to grab the throttle leader, confirm it with my colleague, the fact that I've got the correct engine, so I'm not shutting down the wrong engine. I'm going to slowly retard the throttle lever until the engine stops surging, I reach idle. If I reach idle, I'm then going to grab the fuel control cutoff switch, which should be right next to where my hand is, confirm that with my colleague that I'm going to shut down the correct engine because we don't want to shut down the wrong engine. And then we move that to cutoff. That is the checklist complete for pattern matching for me as a pilot. And the reason I can say that is because there is a rule-based, but I've pattern matched it because I've trained my chimp. And we'll come on to that a bit more in a wee while. When you don't have a lot of cognitive thinking time, like I say, you're driving along the road, a child runs out in front of you, and you hit the brakes, it's because you don't have a lot of thinking time, and your chimp has just reacted. It's taken over your body and just reacted. Decisions are primed by experience. Like I say, you know, for me, pattern matching of seeing an engine surge, I know what to do. I've primed it with experience. I trained it. You're driving your car, child runs out in front of you. Yeah, you've trained because you've driven your car for, I guess, many years. You know how to hit the brake pedal and hit it quickly because, you know, you've had instances where this has happened before. You know, you've been in the car park at the supermarket and someone pulls out in front of you. You know what to do. You've trained your chimp. And review, you need to think about what you've done because it's really, really important because the chimp may have taken over and taken command and carried out a chimp naturalistic response. But it may have been the fact that actually, if you don't review that, you know, you've hit the brake pedal really, really hard and you've got a boss that was just behind you is now going to hit you in the back. You know, could you have swerved? You know, you need to review the situation. Really, really important. We'll come back to a bit more of info on that later. The analytical, this is the human. This is where you can think it through. This is if you have a lot more time. I'm not saying, you know, we've got days, weeks, months to do this. If you've got, you know, a minute or two, you know, 10 minutes, 15 minutes, if you've got a bit more time, you can think it through. But time takes effort. You need to, you know, calm the chimp down, feed it a banana is what we say on the flight deck. You know, give the chimp a banana, keep it calm so the human can step in and think it through. So as I say, you need to cage the chimp, keep it quiet, give it a banana. And it helps to have a framework. Now, the framework I'm going to talk about today is one called TDODA, and we'll go through that in detail. But the first thing to do is to keep the chimp calm. A trick that we're taught as airline pilots is, you know, setting your hand, wind your watch, just take a second or two. If you can, if the situation warrants, and it's very rare that there's a situation that needs an instantaneous response. Take a deep breath, breathe in, 1, 2, 3, breathe out, 1, 2, 3. Right, what have I got to do? Just that few seconds is enough for the human to step in, calm the chimp down, and say, right, what do we need to deal with? What is it we're facing here? What have we got to do? You know, and then you can think through it, you know, rationally, logically, and hopefully come up with a better outcome than what if you just let the chimp fight their way through this, because the chimp's going to be rattling in the cage and be very angry. And this also means that the human can generate some options and think about, you know, how are we going to solve this problem. Rule-based, this is shortcuts. This is somewhere in the middle. So if you don't have a lot of time, you know, you've got a minute or two, you haven't got time to think it through too much, you know, you don't want to rely on the chimp because the chimp makes bad decisions. You're just going to rattle the cage and get really angry or run away. You know, so somewhere in the middle is the rules. Rules, you know, are quick and easy. It's something you've trained to do. So like I said a moment ago, I talked about the fact that if there's an engine surge, there's a set procedure for me to follow. There's a checklist for me to follow. Everything we do in aviation has a checklist, everything. And because of that, we know these checklists because we use them day in, day out. We know these checklists, you know, off the top of our head, but we still get a bit of paper out and we go through the checklist. And we get this big, thick book, actually. It's called a QRH Quick Reference Handbook. We go to the correct page. We know which page it is because we train to go to the correct page, and we read through the checklist nice and simply. Now, there's no reason that us as software engineers, developers, engineers, managers, project engineers, whatever it is your day job is, there's no reason why you can't have a checklist to go through things to make sure you don't miss stuff. Don't just, you know, rely on, you know, your brain to remember this stuff. Don't rely on the fact you've done it, you know, a million times before, because that one day when you're rushing because, you know, the crap that's hitting the fan, you'll miss a really, really important step. You'll miss to, you know, to click that build step that needs to be clicked to make sure that it goes to, you know, to the pre-production environment rather than production, out to, you know, the outside world. So make sure you have a checklist, and also having a checklist, the more you use it, the more you train the chimp that if you see the situation, don't panic. We've got a checklist for that, and here it is. Decisions feel more intuitive because you've got a checklist, because you've got something that has been in the cold light of day, has been looked at, has been analysed. You built your checklist. You've thought about what it is that you need to do in the steps and the correct procedure to take it. That if the production server goes down, and you know your website Amazon.com's just gone down, and it's your fault, and it's Black Friday, and all hell is breaking loose, and your manager's stomping down the stairs towards you. If you've got your checklist, you can go through. How do I need to put this back online? What do I need to do? Because all the pressure, everyone's looking at you. You've got a checklist. You can just nice and calm, just go through it a step at a time, rather than rushing and clicking all over the place and making poor decisions. And someone else has done the thinking. It may have been you in the past. You know, past you is paying forward a bit of help to future you. So make a checklist. If there's something you do, you know, often that, you know, could be done in an emergency situation, or, you know, it has to be done in a hurry, then, you know, write up a checklist. What is it I need to do? Set out some rules. Give the checklist to somebody else and say, does that make sense? You know, does it work for you? You know, can you follow these steps as well? Because it could also be the fact that you make this checklist, and then, you know, 6 months, a year, 5 years, whenever it is, you decide that, you know, your career progression takes you out of that business to another business. Your plan back to your colleagues is, you know, if you see this happen, here's a checklist. Here's what to do. So that when you do move on, they don't have to try and, you know, frankly find a personal mobile number for you and give you a frantic phone call at 2 o'clock in the morning and say, pretty please will you help us? It's all gone horribly wrong. So, you know, making these checklists is helping yourself, not just your colleagues as well. And there's shortcuts as well. It's a way of helping you because the checklist is nice and easy. You can nice and calm, breathe slowly and work through a checklist. But the chimp is involved. The chimp is still there, rattling the cage, panicking and worrying. So just be certain that you know, you take nice deep breaths, oxygenate your bloodstream, which gives nice oxygen to your brain and allows you to brain to think through these issues as you're going forward. So daily decisions, you know, there's 5 things there that, underneath my decision list that I put together when I did the slide deck a while back. And now all things that happen to me on a commercial aircraft with, you know, a couple of hundred passengers sitting on the other side of a flight deck door. And they're all things that have happened. Struck by lightning. I've been struck by lightning, you know, a few times now. and the aircraft's fine. We have a procedure we go through. It's not because we've been lackadaisical and flying too near a storm. We haven't got the weather radar on. Sometimes you have to pass through a storm cell. You have to, there's a whole line of storms are there, and you have to pick the best path through, and unluckily you get struck by lightning. The one that I think of here when I put this down was the fact that it was climbing out of Toronto. It was late at night. We could see stars. It was a clear night. It was, really crisp winter's nights. And we was climbing out, and we passed into a patch of cloud. Nothing on the weather radar whatsoever. And it was really dense cloud. And a few moments later, we got struck by lightning. It's like, well, that was a bit of a shock. But now, do you think that was a chimp response or humanistic response of being struck by lightning? Well, initially, it was a chimp response because, the lightning struck just to the right-hand side of the aircraft where I was sitting, just where my backside was sitting on the seat. I jumped, and there was, even though I got a 5-point harness, there was clear air between my my butt and the seat, and I screamed a big banshee scream because it shocked me. As I'm sure it would you if you sit in the same place. Captain was sitting to my left-hand side. Shocked him a bit as well. But then he burst into fits of laughter because his humanistic response kicked in, and he thought it was hilarious that I jumped and screamed like a big girl. But then the training kicks in, and then we go to our wall base. Right, there's a checklist for being struck by lightning, and then we look at the aircraft systems: aviate, navigate, communicate. Who's flying the plane? We confirm who's flying the plane. Are we going to continue on this path, or do we need to turn away? Well, there's nothing on the weather radar, and we've just gone back into clear air again. We can see stars, we can see the ground. So, initially a chimp response, but then, we're trained, as I say, to cage the chimp, feed it a banana, and take over with the mental thinking of the humanistic. Engine surge, I said that I've had an engine surge. I've only had one in my 18, 19 years now of flying commercially. We got to top of climb. We'd just been fed our breakfast by the cabin crew, and sitting there with a nice English breakfast, and just put the first forkful of sausage in my mouth. And aircraft just starts to level at top of climb. Engines start to roll back as they do at top of climb to reduce the power for the cruise. And just as they start to do this, bang, and the aircraft starts swinging all over the sky. Bang, it starts doing it again. It pops up with an ECAM, which is our alerting system on the Airbus A320 that I was flying at the time. And it gives us a warning, engine surge. A fork full of foods, a tray of food on the table in front of me. And it wasn't, ideal time for this to happen, but that's when it happens, when you least expect it. So, chimp response or human response. Initially, it was a chimp response. I was angry that I wanted to eat my food. I was hungry, but yeah, it was a human response. Who's flying the plane? Right, you're flying the plane. I'm going to clear my food away, put the food to the side, put the table away. And then I took control. The captain did the same. And then we dealt with the situation. We went through our emergency procedures and dealt with the situation. Medical emergency, pushing back off stands. We're just pushing back, moved 5-10 feet off stands. And had a call from the back from the cabin crew saying, Captain, and they never ever call. When we start moving, they're not allowed to call us unless there's an emergency until we're airborne and the gear is up. Unless there's something they need to call us for, an emergency or something's happened. So it's highly unusual that they call. So pushback was saying, Captain, I can just see down the back that there's a bit of a kerfuffle. There's passengers up, standing up, and hold on. I can see someone on the floor now, and I can see the crew leaning over them. It looks like they're giving CPR. Give me a minute, and I go and find out what's going on. And the line went dead. So do you think human, or do you think chimp response? Well, not that, it was a human response. Again, not something we've seen. There wasn't a rule. The chimp was pretty calm because the chimp was, it was sitting on the ground. It was quite happy. It was like, well, there's nothing going on. I'm not at risk. But there was a pretty big emergency going on behind us. So again, we can take deep breaths, breathe in, breathe out. Okay, what we're going to do? We start the push back. We got the emergency services attend. The cabin crew got the heart start kit out and started giving the heart start, which is the jump starts you see on the movies. And thankfully saved the gentleman's life and got a pulse by the time the paramedics arrived. So, it's, the training kicks in. You do what you train to do, but only if you train. Airport closed due to snow, flying back across Atlantic from Newark back towards London. and we got the latest weather, and it said that the airport was snow closed. Hold on, snow closed? We wasn't expecting that. There's no snow forecast. What happened here? You know, it was only a small chance of snow. Now there's enough snow to close the airport. So, you know, chimp or human? Yeah, again, it was a little bit of chimp initially. It was like, well, my car's parked at the airport and I want to go home. But yeah, the human kicks in quite quickly. Everyone starts talking, other aircraft on the radio. With, you know, across the Atlantic, we have a chat feed and see that we all chat on. And we're using that to chat amongst ourselves to find out, you know, what other airports are available and who was thinking about going where. So we didn't all rush to the same diversion airport and clog that up instead. So, you know, a couple of hours of thinking that through as a human response, but, you know, time's ticking down. And the baggage system failure early morning. This was one that happened in Helsinki. The baggage system failed and, you know, we're having to deal with it. But again, it's on the grounds. You know, the chimp's quite happy. So the human response kicks in. So I'm just going to grab some water. So we use, as I mentioned earlier, this model in the airline that I work for called TDODAR. And that stands for time, diagnosis, options, decision, assign, and review. So this model was developed initially by NASA, I'm led to believe, back in the Apollo era. It didn't have the T on the front, it's more DODAR, and I think the middle D was different. But it's a model that's been used for many years in aerospace industries, both, you know, space and aircraft. Us at our airline added the T some 10, 12 years ago because we realized at the time it was always part of the decision-making model, but it was never written down as this mnemonic. So we added it a while back. So we'll go through each of these and talk about what we think about as airline pilots. So time, how much time do we have? Is an emergency, do we have to act quickly? Is there a rule that we need to follow? Is there a checklist that we made? If not, make sure we make one later. Do we need to, and can we make more time? So, you know, can we make more time? Is there a way of, you know, standing up a backup server that will just keep us limping along for a couple of hours while we sort out the main problem? You know, is there a way to do this? You know, for us, if we've got a problem on approach, we'll go around and climb back up again and take our time and sort ourselves out and come back around for another approach. Maybe we're flying towards this snow-closed airport. We could slow the speed down. You know, if you fly slower, you use less fuel, and you buy yourself more time. You can buy yourself another 15 to 20 minutes if you need to. One of the things we talk about quite often is, do we have time for a cup of tea? You know, us Brits, we love our cup of tea, and that allows you to just take 5 minutes to individually just think through the problem without jumping into let's solve this, let's fix this, just get it done now. If you have time for a cup of tea, then you can nice and slow and think it through. But the important part is to start a stopwatch. You know, as soon as something happens, there's an instant, start a clock, write the time down, whatever it is you're doing, look at your wristwatch, start something on your iPhone, record the time. It's very important to do this because it's very easy to lose track of the amount of time you spent on a problem. There's a great book you wish to read called Black Box Thinking by Matthew Said. And this book at the beginning talks about a young lady that goes in to have a routine operation. She gives her husband, who just happens to be a commercial airline pilot as well, a kiss goodbye and I'll see you later, honey. And when you go to shops, can you get this and this and pick me up in a couple of hours? It's a routine operation. It goes into the operating theatre. In the operating theatre, the anaesthetist, anaesthetizes the young lady, and she has an allergic reaction to the anesthetics, and the airways start to constrict, and she's not breathing. So the surgeon that's there, quite a junior surgeon at the time, tries to put in an airway and tries to intubate her. Can't do it. So a senior surgeon steps in, says, "Get out of the way, son. I'll show you how to do this," and steps in and tries to intubate, and tries to do it and fails. By now, the registrar, the most senior doctor, surgeon, has come rushing into the operating theatre, and there's 3 of them there, all highly trained professionals. Again, tries to intubate, 11 minutes pass before they get an airway by doing emergency tracheotomy, which is where they do the cut just here and get an airway. But by then, 11 minutes of little to no oxygen to the brain. And sadly, a few days later, she passes away. Now, the whole time, there's a junior nurse standing there with a tray with the emergency tracheotomy kit, and was kind of stepping forward, you know, doctor, do you want to do an emergency? Because she knew how critical this was. She knew what needed to be done. But because these doctors hadn't looked at the time, hadn't started the stopwatch, afterwards when they're asked, they thought only a minute or two had passed, not 11 minutes, because they hadn't started the stopwatch, because they didn't know the time, because they didn't work as a team and work out, well, you know, how long we got, what's going on. So T is really important. It also stands for team. It's a team exercise. Your team needs to solve it. And just like I highlighted there, the junior nurse is standing there in an emergency tracheotomy kit. Because she's junior, she feels she can't speak up. She feels she can't step forward and butt in because, you know, the senior people in the room, the director, the team leads, you know, whoever it is in your team is leading the situation from the front, and, you know, gung-ho and off they go. And this, you know, quite meek nurse is standing there with the correct kit to save the day, but feels scared. So make sure, if you do work in a team, if you're a team lead, make sure you, when you start this, or if you're planning to go into a situation where you know things could go horribly wrong, make sure you tell your team, look, I'm human, I'm fallible, just like you are. If something happens, you know, I'm Cliff, shout my name, it will get my attention. Yeah, and that's what we do. So I hear my name shouted on the flight deck. So, okay, right, we need to work this together. And then you've got my attention, and tell me calmly but quickly what it is you think. And it could be the fact they give you information you already know, or, you know, you don't care about. That's for 10 steps ahead. Doesn't matter. Just listen to it. Okay, I've got that. Thank you very much. And this is why we're not going to do that, or this is why. You know, I'll come back to that in a moment. But T is for team. You need to work as a team. That's how it works. B, diagnosis. What do we think happened? Discuss the symptoms. I'm not trying to fix it yet. All we're trying to do is work out what we need to fix. So discuss the symptoms among the team. This includes all the team. Ask open questions of each other. An open question is a question that cannot elicit a one-word yes, no, maybe, don't know, kind of, don't know, 2 words, but you get what I mean. A single response to the question. So if you're having a problem on board the aircraft, ask, or in your development team, ask a question that makes them stop, think, and give you a long answer. Because to give you a long answer, they have to stop and think about what they're going to say. Also, if they try and give it to you in a hurry, you can tell by the intonation and speed of their speech that they're panicking. And then you know that actually I need to deal with this person that's also panicking with the situation. So it gives you a lot of information just by asking an open question. Find some info and tell you why it's not this. So the main production server's gone down. And, you know, find out why it's, you know, why it can't be your software. Could it be hardware? Could it be the software? Could it be the fact that there's a power cut in the city? And, you know, so find some info and say why it's not something different, you know, and this is just generating the diagnosis. You know, our server may be down here and we can't see it in our building, but we may have an internet failure in the building and the server could be fine. The rest of the world can see it and happily doing their Black Friday sales purchases. So, you know, just think about, you know, when you're diagnosing it, don't just jump for the obvious. Agree what needs to be tackled. So as a team, say, well, okay, you know, the engine's fouled, the production server's down. This is what we've got to fix. We've got to fix this situation. And agree as a team. And that means you're all going to be going forward together rather than all rushing off in different directions. You've all got different ideas. Make it quick and concise. You know, the clock's ticking. You started that stopwatch, didn't you? So, you know, be certain that you'd be quick about this. O is options. Now, I don't really need to labour this one. You've all brainstormed before. You've all stood there in front of a whiteboard with the pens and written down a list of things that you're going to do. That's all this is. On the flight deck, we tend not to write them down unless we've got plenty of time. We'll make a list. But yeah, just keep it short and sweet and just come up with a few options of how to fix the problem you're facing. Not what you're going to do, just options of how you're going to fix it. A good one, if the list is really short and you're the team lead and you think you've got a few moments longer, pick someone in the team, give me another option. And the good one to do here, when I've gone into companies and helped them through a process like this to fix, say, a major problem, I always pick the person at the back that's quiet. The reason being is they're typically the junior person. They're typically sitting there and they have a completely different kind of perspective of the situation, of the team, of the build tools around them, and the way everything's built up, because they're typically new, and because of that, they give a gem of an answer. They give a gem of an option, and that is typically, you know, something that gets picked up and used, and they feel great about that, because then, you know, they get the huge pat on the back from management later. So take input from all members in the team and outside sources as well. So for us, it'd be air traffic control, the cabin crew. For you, it could be giving a customer a call. What do you think of this? Giving the internet company a call, giving, you know, the hardware engineers a call, giving sales marketing, the business teams a call, and you know, speaking to them, because if it's affecting them, they may have a different way of doing things. So take input from all sources. No such thing as a silly idea. If you think it's silly, just verbalize it anyway, because your silly, stupid idea that you think is, you know, stupid, it's never going to work. But, you know, just say it, because your silly, small idea could be the acorn that grows the oak tree of someone else's fantastic, great idea. You say something silly and someone says, you know what, that's silly, but you know what, we could do this instead. And it gets people thinking. Don't drag it out. Often the first, you know, 2 or 3 ideas are the ones you need to pick from anyway, and the clock is always ticking, so be aware of that. D is decide. What are we going to do? As a team, you decide. The important bit here is, as a team, you decide. This isn't a management, right, we're going to do this. Because if the manager picks, the team lead picks, you know, the project lead picks, and it's not been a team decision, you've not got the team with you. I've seen this happen time and time again in teams, where the team lead says, right, off we go, we're going to do this. And the rest of the team's like, oh, really? But this one's such a, you know, this idea is stupid. This idea over here is much better. You're not going to take the team with you. So as a team, decide what you're going to pick. If you're the team lead and you've got a reason why you want to pick this, what you perceive to be the better idea, voice it. Tell the team, look, I think this is better because X, Y, and Z. Don't just say, no, we're doing this, and thump your fist, because it's not going to work. Don't spend too much time picking an option. Just pick one and go with it, and state the decision to everybody. You know, write it in big words on the whiteboard if you have one. Stick it in an email, on a Slack channel, wherever it is, wherever your team talk. State the decision in big bold letters, so that everyone is in, you know, no uncertain terms, knows exactly what it is you've decided to do and how you're going to fix this problem. And important as well is failure to decide to fail. That comes from the Apollo 13 era. Gene Kranz was, you know, we need to pick an option here, and we need to get on with it, because failure to decide to fail. The clock is always ticking. If you had 20 minutes to fix this problem, you know, you've already taken 10 minutes to get to this point, and you take another 10 minutes to decide what to do. You're not going to fix anything, are you? So you're wasting time. So just pick one and go with it. If you're not sure between 2 or 3 different avenues, just pick one. Doesn't matter which one, just, you know, toss a coin, just pick one. And then what will happen is that your decision will generate more issues or more fixes. And from that, you can then decide that actually, you know, we've gone down the wrong path. We're human, we've made a mistake. Let's go back to our options list, review, and then we'll pick this different decision and go down that path as well. Assign. This is the bit where you actually assign tasks. This is where the team leader, and this is the first time I've really mentioned the team leader, you know, stepping forward and doing something. This is when they assign the tasks. The team leader does this because they know the strengths and weaknesses of their team, or they should do, hopefully, if they're a good team leader. And they can make sure that the correct tasks are assigned to the correct person within the team. Make the task short and within that team member's skill set. And you want it to be short. And the reason you want it to be short is because you need to report back to you and say, right, I've done that bit. Now, I'm not saying just give them little bits of information, and so they're kind of fighting this in the dark, but tell them the big bit, but just say, right, can you just do that small part for me first? Can you, reboot the computer and see if it comes back on. I don't know, whatever situation you're dealing with, but give them a short task and get them to report back to you when that bit is complete. And then you can manage the situation as a leader, because you can see the different bits coming back to you. And then you realize that if that person doesn't come back to you in, you know, the allotted time, 5, 10, 15 minutes, you know, end of the day, wherever it is you're dealing with, then you know either they've sunk, or there's a bigger problem, or they're struggling, and then you can step in and help them, you know, get another team member in there to help them with the problem. If you're the person that's been assigned a task, it's not a race. Do it quickly, concisely, follow the checklist if you have one. If not, make a note to make a checklist later. But complete it as quick as you can without delay. If you can't complete it, hand up. I'm thinking over here. I haven't a clue. I don't know how to do this DevOps stuff. You know, I don't know how to turn the computer off. Whatever it is, you know, ask for help. You know, because failure to ask for help will come up later if you're still there 2 hours later and the team has sunk, and the problem is taken over. Everyone's going to be pointing, you know, didn't know what they were doing, and you know, you'll be the talk of the water cooler and the coffee machine, or Slack these days, where the fact we're not around the coffee machine. But you'll be the talk of town because you didn't stick your hand up. Stick your hand up, being honest. You know, everyone will be like, oh, yeah, Cliff, he wasn't sure what to do, but yeah, he got us help and we got it sorted. It was fine, and that'll be it. Be forgotten then. So you know, us as humans, certainly as software engineers, we're sometimes scared and meek and quiet, and we don't want to stand up. But trust me, just stick your hand up and say, I need help. If you're the team leader, consider overload. If you've got any emails from your team at 2 o'clock in the morning, is that the right time to be getting emails? You know, if that person's typically up at that time, then yeah, fine. But if they're suddenly sending you emails at 10 a.m. and typically they're in bed then, you know, just consider overload. You know, if you're seeing communication or lack of communication, as a team leader, you should know the patterns of your team. If you're seeing something that's out of the ordinary, consider overload. Check in with your team members quite often, make sure they're okay and they're dealing with the situation well. And then the last one is review. Everyone forgets this. Have we fixed the problem? Do we still have time on the watch? Yes or no? And then quickly about for the team data, we've still got 5 minutes. You know, did we diagnose the correct thing? As something else happens that has popped up that we need to diagnose and fix? Did we have different options now that we need to pick? Do we have another decision to make? Can we assign more tasks? You keep going round and round and round, and the review is really, really important, because it's the review that will point out if you made a good decision, if you fixed the problem. And also the good bit about review is when you've completed the task and you've you know, gone for beers and pizza and celebratory slaps on backs, the important part of review is, can we make a checklist that can make this easier next time? Can we make a log of, you know, we love having log files that log out the errors and you know, in our code, but do we log down when we deal with a critical situation? No, most teams don't. Do we log down and create a checklist of how to fix this in the future? Probably not. Most teams don't. Hopefully now, having seen me give this talk today, you'll go back and think, actually, let's log that down. Let's have an operations log in the office, you know, or on Slack or somewhere where, you know, we've seen a problem. We write down what the problem was, how we fixed it. We write down, in using the TDODAR model, it took me 20 minutes, and this is what happens. Don't be scared to change your mind. If you get to review and you've not fixed it, the clock's ticking down, you've got 10 minutes left, and it's like all gone to a ball of chalk and you don't know what to do. Calm, deep breath, start the beginning. Right, I've got 10 minutes now. Diagnose. Are we actually trying to fix the correct thing? Go through nice and slowly. Yeah, we're human, we make mistakes. Be honest, stand up, and just say, yeah, I made a mistake. So that's the decision-making tool we use, TDODAR. I use it pretty much every day I go to work. I even use it at home. You know, do I have time to watch the Formula One on the TV before the wife gets home from shopping? You know, whatever it is that I need to do, I use it in my software development world when I'm working in with teams in bigger companies. As a freelance developer, I go in there and you use this model. A couple of my clients that I go in and work with quite often, they've embraced this, and they have checklists and an operations log that everyone writes in if they see something happen that they're not quite sure what, why, and how. They'll write in the operations log, so that if something happens again, you can quickly look through the operations log, and it might help you generate the options if you have the time. Review. We've not said it once, twice, or 3 times. I'm going to say it again. Review everything you do. So that is the flight deck of the 787. I'm next off to Dallas, Fort Worth at the weekends, and I get to fly a bunch of cargo out there. Probably no passengers now that in the UK we've locked down again. I dare say I'll be making decisions, and we'll be using the T-Dodo model. But when will you make your next decision? What is the next critical decision you need to make? And hopefully the T-Dodo model will help you, and hopefully you don't rely on the chimp to fix the problem, but the human, the brain, to fix it. That's my talk. Typically when I give this talk in person, we go through a little exercise in Teams just to cement this. A bit difficult when I'm talking to my camera, my googly eyes in front of me, and you're sitting in your room or office watching me on the internet. But hopefully if you catch me at in real life event in the future, giving this talk, you'll come along and take part in one of the challenges that I set. Thank you very much, and that's enough from me.
Bel atterrissage en douceur.
Ouais, il a été parfait. Pas de turbulence pendant le vol.
Non.
C'était juste nickel.
Moi, je suis presque rassurée. Hein.
Presque.
J'ai presque envie de prendre l'avion dans des conditions évidemment hors Covid, mais.
Ouais. Franchement, c'était classe. C'est
Ouais.
vraiment. On était en première classe cette année.
Vrai.
Le 16 novembre 2020, on peut dire que le DevDay nous a mis en première classe chez British Airways.
C'est vrai. Et demain, c'est pareil.
Et demain, c'est pareil. Mais demain, on est au-dessus encore. Et demain, par contre, on reste au sol. On se met en lounge, on se met bien. On se pose dans le divan et on regarde 3 tracks.
Ça commence à quelle heure?
Ça commence à 9h.
9h, 3 tracks.
3 tracks en parallèle, par contre. Donc, il faudra choisir. Malheureusement, il y a du choix à faire, mais on vous promet qu'on gardera les sessions pour vous les donner plus tard.
C'est très cool.
Mais par contre, il faut être là demain parce qu'il y a plein de choses à découvrir. Et le mieux, c'est de pouvoir poser des questions au speaker en même temps directement.
Et on espère que vous avez tous apprécié ces sessions. C'était vraiment du haut vol, sans faire de mauvais jeux de mots.
Exactement. Mais par contre, si on est là aujourd'hui, c'est grâce à nos sponsors.
Yes.
Ouais. Et donc, on leur remercie encore à nouveau.
Ouais.
On leur dit que l'année prochaine, on les attend encore avec beaucoup d'impatience.
Et on en attend d'autres, peut-être.
Espérons-le.
On ose le dire.
Ouais.
On ose le dire. Cool. Excellent.
Et
tu penses que cette 7e édition, elle est plutôt réussie là pour le moment?
En tout cas, aujourd'hui, elle a été réussie.
Excellent.
Je voudrais juste terminer par te remercier, Charline.
Avec plaisir. À votre
été
service.
Une Master of Ceremony de grande qualité.
J'essaie.
Et on espère te revoir l'année prochaine.
Absolument. Je serai là. Je vais camper ici. Je reste là. Terminé.
Bruxelles, la Belgique, c'est ton pays maintenant?
Absolument.
Il y a beaucoup de bières. Hein.
Je dis oui. Je dis oui.
À l'année prochaine.
À l'année prochaine.
Salut.
Salut.
À la prochaine.
Ciao.